All right, good. We're going on YouTube too. So I was just thinking that I think last week I started a problem from chapter 3 of the physics book, and I kind of want to finish it. 3.13. This one. So we did part A, which had some tedious calculations, but really wasn't so bad. Let me just look at the work that I did, though. That's what I have on my board at the time. So what did I say? Let me read the initial, like, prompt. The locus of points with phi equals 0 is a circle on the xy plane and hence a spherical shell in space. And so what we did is we added their potentials, set them equal to 0, and you have a whole mess of constants here, which was super annoying to deal with. But Cook used Mathematica to ensure that this was actually done properly and that I don't mess with a sign or a constant or something. That's got to be Joseph. Congratulations on the first. And so I think this is I'm trying to figure out how to read this output. Oh yeah, okay, so I think this x0 is the x-coordinate of the center of the circle, and this r is the radius of the circle, and this is just the lower half of the circle over here. You see if that agrees with what Cook put in like text. Yeah. Maybe Spetry, I don't know. Who's to say? Maybe there's a secret message, I don't know. Maybe I'm just putting random letters in there. But also, I did this command here. Wait for it. There we go. It takes a second to actually run, but yeah, no worries if you're just gonna say that one thing in dip, but how many is Joseph up to? Joseph has gotten a few. Wait. Oh, because of the name change. But you just got one. I wonder... Huh. Does it still go under your old name? That's weird. Okay. It was the name change that messed it up. Huh. So... Okay, so we've done part A of this problem here. What's part B? What must be the relation among Q, Q, A, and A so that the center of the circle is located at x equals 0? Sounds good, Spetry. I'm not saying there is a message there, but if there is a message, it might be very important for the world to hear it. But you know, there is no message. It must be in your imagination. Yeah, bye. Well, I mean, part B here is not so bad. I guess I'll write it on the board just so we can refer back to it if we need it, but actually, let me write up the equation in the circle here too, so I assume we're going to need it. X minus and the x0. Just sneeze there. Big A, small q squared. Minus small a, big Q squared. Over small q minus big Q, both squared. Squared plus y squared equals, and then our r squared. Or q squared minus q squared. Squared. Okay. So with regards to part B, in order for the circle to be centered at 0 or like the origins 0, 0, this thing must equal 0. Oh wait, so these can't be equal, can they? Well, I guess. Oh, the A's must be equal. This implies that big A equals small a equals 0. Because, but that would imply the radius is 0, which seems bad. Does that need to be an absolute value of ours as well? It doesn't affect the answer to this problem. Yeah, I think just the entire thing needs to be an absolute value. And that's what Cook said too. Because the a minus a, you also just want the positive. So that seems weird. Is there, I don't think there's another. Like way that we can get this thing to be centered at 0 though. Because we can't have q squared minus q squared equal to 0. Okay. So I assume that's good for part B there. Oh, hey, Eldritch. 3 times of which number is no greater than 2 times of the same number? It has to be 0, right? Eldritch might still be watching ads. Lemon over on YouTube says, can you help on this question? An equilateral triangle and a regular hexagon have equal perimeters. If the area of the triangle is 4, what is the area of the hexagon? I could probably figure that one out. Let's think about it. They're over? Okay, Eldritch, my guess is 0. I don't know what other number, maybe a negative number. It is 0? Okay. Equilateral triangle and regular hexagon have equal perimeters. Ignore this stuff up top here. So wait, equilateral triangle. So boop, boop, boop. And we'll call that T for triangle, the length of the side. 1, 2, 3, 4, 5, 6, and we'll call that H for hexagon. So we know that their perimeters are equal, so 3 times T must equal 6 times H. And then we're given that the area of this equilateral triangle is equal to 4. Let me just fact check that. Okay, yeah. We also know the area of a triangle is base times height. The base of this thing we can call T. The height we need to figure out. Because it's an equilateral triangle, we know that's a 60-degree angle. We don't actually even need the angle. What we've done here is we've made like a little half right triangle. This bottom part is T divided by 2 because the entire thing is T and we just cut it in half. This side right here corresponds to that side right there. We know that's T. And then by this thing over here is the height, and we can use the, what is it called? Pythagorean theorem, there we go, to work out what the height of this is. Which is going to be the square root of T squared minus T over 2 squared. Because that's the hypotenuse, you subtract out the other leg. Oh, is it going to be 6? Oh, I will say, Jed, $10? That's cool. I'll read the rest of the chat in a second. Okay. So we can solve this thing for T, and then come up to this equation to figure out what H is. And then once we know what H is, I assume we can get the area of the hexagon. I wonder if there's a quicker way to do it than this, but this way should work. This is annoying, isn't it? t squared minus 1/4 t squared. I guess what we can do, we can factor a t squared out. That'll make this a lot simpler. So I'll show each of the steps of this because the algebra can be a little bit tricky. I'm going to take inside of this, I'm going to factor out a t squared. So we're left with a 1 minus 1/4. Now, when we have two things multiplied under a square root, we can split up that into two separate square roots. So we can have the square root of t squared times the square root of 1 minus 1/4. The square root of t squared is just t, and t times t is t squared. 1 minus 1/4 is 3/4. All right, we're nearly there, at least for the value of t. When you have the square root of a fraction, you can split up into two square roots in a similar way. The square root of 4 is just 2. The square root of 3, we can just leave it as square root of 3. So we end up with 1 times root 3 is root 3. 2 times 2 is 4, t squared. Now let's isolate t, multiply each side by 4 divided by root 3, up here. We get 16 over root 3 equals t squared. Wow, that's going to be an annoying number that we get out of this. Let me rationalize the denominator first though. Multiply it by root 3 over root 3. To get 16 root 3 times root 3 is just 3, equals t squared. Now I'm going to take the square root of each side. The square root of 16 is 4. The square root of the square root of 3 is the 4th root, which is where this gets a little bit weird. And then that 3 on the bottom gets its own square root. And so technically we need a plus or minus here, but we're talking about distances, so we only care about the positive case. So I'm going to erase it. After 100 years over on YouTube, that's a incredibly difficult integral that I can probably find a video about it, but I definitely can't do that one blind. Oh no, Jed. Yeah, are you putting the easy way of doing this? Shoot. That might be so much, you know that h is 1/2 t. How do you know that? Oh, right. Oh my god, there is an easier way. All right, Lemon. I'm doing it the hard way. Because I'm bad at geometry. Ignore what I did here on the board. After 100 years, I already addressed you. That's a crazy difficult integral. You should just Google it because it's incredibly long. Okay, so let me this way it technically works, but you can do it so much simpler. Because what Jed over on Twitch has pointed out is a hexagon is really just 6 equilateral triangles. And get rid of this. From this relationship here, we can divide each side by 3 to get t equals 2 times h, or t over 2 equals h. So we could take the same hexagon, and instead of h, we could have everything being t over 2, and it's the exact same hexagon. We haven't actually changed anything. And then what we get is an equilateral triangle with length t over 2. And we know what the equilateral triangle with length t has. Is 4. And if we if we cut the side length of this equilateral triangle in half, what happens to the area? How does that affect the height of this thing, I guess? That's what we need to figure out. So going back to this drawing over here, we said it was t squared minus t over 2 squared. And we need to work with this a little bit just to figure out how it works. So I'll do the same thing that I did in the algebra before and factor out the t squared. So we get 1 minus 1/4. The t squared could come outside now and get square rooted, and we get root 3 over 4. Okay. So we know that 4 is equal to 1/2 of the base, t, times the height, t root 3 over 2, because the 4 can get square rooted. So if we cut t in half now, to match this equilateral triangle here, we know, or we should get 1/2 t over 2 times t over 2 times root 3 over 2. Just, wherever we see a t here, we divide it by 2. Now let's bring these over 2's out in front. So that 2 times 2 is 1/4. And then in parentheses, I'm going to put the original expression. I shouldn't. This is a different. This is the area for the hexagon, or part of the area of the hexagon. So that 1/2 stays there. T times root 3 over 2. And we know that this quantity is 4, which is why I did this kind of weird looking 1/4 out front thing. So we get 1/4 times 4 is just 1. So what we found is that this area in this part of the hexagon is 1. And a hexagon has 6 of these things, so we multiply it by 6. Six times 1 equals 6. That's the easy way of doing this. Not the way that I at first tried. Okay, I hope that makes sense, Lemons. Sorry for the... little... not wrong approach, but bad approach. No worries. Thank you for the question. Talos, I can't believe you would accuse me of doing something so childish and immature, okay? I would never make a stupid joke like that, for sure. Also, the thing you said about the coding problem 2 days ago, it gave me a good idea when I revisited your comment later on, so thank you for that. Yeah, Malcolm, it was way easier. Oh, syntax. A person in YouTube chat wanted me to integrate the square root of cotangent, and I'm not going to do that. Okay. Let's see. There were some chats earlier that I missed. If 7 people meet each other, this is from Eldritch. If 7 people meet each other and each shakes hands only once with each of the others. And each shakes hands only once with each of the others. Oh no. I feel like I've heard a problem like this before. Is it 7 factorial? It feels like it. I think it's 7 factorial. Then syntax error said, okay, Mr. Fancy Pants, if the integral of e to the negative x squared over the real square root of pi, then why can't I pass finish? I can't answer that question. I was getting to Eldritch's other one. If two math books were complaining, what would they say to each other? Wait, is this a joke or a riddle for me to figure out? I low-key want to drop this term so I can preserve my sanity in my A's. Oh no! Okay, nicely divide both figures into equilateral triangles of area 1, 4 in the triangle, and 6 in the hexagon. Oh, you see your pin. Oh, that's what. Oh, that's okay. That's also clever. Well, yeah, you should have to show if you divide the thing into a triforce, the equilateral triangle, you do have to show that it's area 1, right? Actually, no, you divided it into 4 equal parts. It's really easy. Okay, you're right. There's an even easier way than what I did. Every time I come in here, you're always doing things like you know, why do things the easy way, Malcolm, when you can also do them the hard way? Then square root tangent almost. Yeah, there's a black pen, red pen video on it that I for square root of tangent. I would not want to do it myself. I posted about how you shake hands. But that is a stupidly large amount of handshakes. Okay, you know what, Stuki? I'm not good with combinatorics and counting, okay? We can't all have PhDs. Isn't it like, you take one person, they shake, I guess, 6 other people's hands. And then you've already counted everything for that person, and so the next person shakes 5 other people's. Maybe it's 6 factorial? It's 21? Okay, then I'm just crazy. 6 factorial is probably way too big, too. Joel Let's have saying 6 to the 6. Apparently the answer is 21, but add and don't multiply? Oh. Really? Oh, for the joke is... Oh, wait, let me reread the setup. If two math books were complaining, what would they say to each other? I have so many problems. It's pretty real right there. You add, so you would add. Well, wait, it's the first one is 6 handshakes, right? Like, so you don't, the first person shakes hands with 6 other people. So is it 6 plus 5 plus 4 plus 3 plus 2 plus 1? I guess, yeah, adding makes more sense. Six plus 5 is 11, plus 4 is 15, plus 3 is 18, plus 6 is 23. So I still am doing something wrong there. Imagine like a sports bracket. 1 to 6 will shake hands, 7 seated. Oh god. If 7 people meet each other, they each shake 6 people's hands, which is 6 times 7. Then everyone is shaking hands twice with everyone. I don't get it. I can't count. I can barely even do geometry. Just look at me. I'm a mess. I would rather do a really intense calculus problem than some... like, I think I have an easier time with an intense calculus problem than like a basic geometry problem or a basic counting problem. I don't know. Mood, aren't we all? Yeah. Don does math, but not counting. All the gifts of the 12 days of Christmas itemized? I'm gonna be here for like 4 hours, Jet. I'm not drawing that. The calculus guy tries counting in geometry gone wrong, not clickbait. Oh my god. Wait. Like, what are all the Christmas gifts? Would I have to draw like 12 geese or some crap like that? That's gonna be way too much for me. 12 days of Christmas. X to the 4th plus 1? I feel like it shouldn't be. I don't know. Maybe it is. Nah, it's not factorable. Unless you want to get into imaginary numbers. Oh, right, you could just visualize this thing. The y-intercept is at 1, and it opens upward. I do that. Should I decide to start streaming? Ooh, are you thinking about streaming, Joseph? Name the favorite dessert of a math teacher. Pie? Got it? Nice. Wait. Oh, no, these are imaginary here. Oh, wait, but you can still break it into... Oh, duh. Okay, yeah, so... You could always boil it down to irreducible quadratics. And linear terms. Which, why doesn't Wolfram give me that? You'd have to take like this term, multiply it with that term, and then that one, and multiply it with that one. Yeah, I'm pretty sure any... Oh god. I mean, you could express... I'm probably gonna get yelled at for saying something wrong here, but I think the entire like point of like partial fractions is that you can make any polynomial into irreducible quadratics and linear terms. Yeah, I don't know if Mbox. Yeah, it does have a nice little... Like, those are nearly the same things. If you can get what the factors are, you could, like what I said before, like, take the ones that match and multiply them to get to the irreducible quadratics. What do you still have? What? The 4th root of -1. Even if you did multiply these two, you would still have the square root of -1. Maybe I'm crazy. How can you get 1,000 from the number 8 using only addition? Uh, 8 does not go into 1,000 because it does go into 400, right? And does not go into 200 is the important bit. It does? Oh, never mind. I'm crazy. Oh, bitch! Brian, thank you so much for the raid. Momo DE, welcome in. Thank you for the follow yesterday. Don does math, but not counting geometry or division. I guess you'd add it to itself 125 times, Eldritch. Does 8 seriously go into 200? Or oh, it does. Okay, I'm bad at math. Oh yeah, you would solve the equation x to the fourth equals -1 in terms of complex numbers. Okay, yeah. Okay. Yeah, 3. I don't know what a French hen looks like. 12 drummers drumming, that's the 12 one. And 11 pipers piping, yeah, that's getting refunded. I'm not doing that. Raid indeed. Okay. So I was working on this number 3 problem before. About during Christmas time? No. Supposed to be doing my essay right now. Well, hey, you're still writing something down. Joel, let's step over on YouTube. Hey, John, I would say 6 factorial multiplied by 7 because we have to take into account that one person, when he first shakes a hand, he has 6 options if he goes. Apparently it's... Oh, I didn't do it right, Eldritch? I mean, what's wrong with 8 plus 8 plus 8 plus 8 plus 8 plus 8 125 times? That is a neat little thing there too, though. What's the sad news, Jed? And Joel, I think that's more or less the right idea, but you're supposed to add. They don't multiply. No! What? It reset your watch streak? Bro! Oh, that sucks. All right, guys, I'm being a YouTube-only streamer. I can't believe it reset on the 100th day. Oh yeah, Waffle, if you like genuinely need help, I'll actually try. It reset 2 days ago? Oh my god. Oh, true, yeah, hence, okay. I didn't do a special stream this week or anything like that. And I don't think my stream like went down and I had to restart it or anything weird. Oh, that's so annoying. Yeah. Oops. Or maybe they just max out at 2 digits, like them Bucks said. In physics, a French hen and a French horn are both spherical and about the same size, thus equal. Yeah, I mean, maybe it's like same issue as like with like Y2K. They're only storing the streaks as 2-digit numbers. But yeah, Waffle, feel free to post your question. I'll take a look. In the meantime, I'll go back to this like physics problem here, but I'll switch over when I see it. So yeah, I want to revisit this chapter 3 problem because we did start it last week, and I kind of want to at least try to finish it. So I just worked through part B before this. And using what Dr. Cook put for the answer, I said that it must be that big A equals small a equals 0. Because if q squared minus q squared is 0, then you're dividing by 0 and things get messy. A French hen is just a female chicken sporting a beret, right? Probably. That's how I imagine it. Eating some, like, stinky cheese. But kind of like the weird thing about my answer for part B is that if small a does equal big A, that also implies a radius of 0. So I don't know what to think about that part, but... I'm gonna look at part C. Assuming the machine found in part B holds, what is... Oh. Well, I just answered part C without knowing it. So just actually write on the board. Question mark? Because that seems weird. Just posted it? Okay. Let's take a look at it. Pies are round and cakes are square. Pi r circled. Can you zoom in on this? Oh, you can. Okay. Yeah, Momo. It could definitely be better, but I do kind of like this like 2cam setup here. So many original solutions instead of the one you, Dr. Cook, showed me. I got a 41 out of 50, not bad. Lost 7 points in prompt one, so what I mentioned about me going in circles with the proofs. Oh no, okay. But that's annoying that you I guess you didn't follow directions there, but like you did the work right. Okay, so this is Waffle's problem here. There are positive integers that have these properties. The sum of their squares of the digits is 50. Each digit is larger than the one on the left. What is the product of the digits of the largest integer with both properties? So this constraint here means that our options are going to be pretty limited, thankfully. Oh, cool, Momo. It's always good to see more people getting interested in streaming math. The whiteboard came to 60 FPS too? Is it? Let me see. Oh wait, I can't easily check it actually. I stream in 60 FPS. I don't know if the actual camera itself is doing 60. It might be. What is the product of the digits of the largest integer with both these properties? I feel like I did a silly, but I can't figure out where or how. Each digit... So you're saying it has to include a 0? Oh, I guess you could always have... You could always put more zeros onto the end of this number? Oh wait, no. You can't. Each digit is larger than the one that's left. What did one algebra book say to the other? I don't know. The sum of the squares of their digits is 50. So say 55 would meet condition 1. Each digit is larger than the one on its left, which 55 breaks. What is the product of the digits of the largest integer with both properties? So yeah, you can't have a 0 and this number. Unless you want to include a leading 0, but that seems kind of weird. It wouldn't actually change anything either. Your original answer was 345. Don't bother me, I've got my own problem. Nice, Eldritch. If you're going to bed now, then I'll see you around, and thanks for dropping in the jokes and the riddles. Oh, 345 gives you 60. Okay. Three, 4, 5. It feels like a triangle. That's 9 plus 16 is 25 plus 25. Okay. Does it help to actually like write the equations? I don't know if the equations are actually going to be helpful here, but like, if your number of interest is D1, D2, D3, like the actual digits, then we know that D1 squared plus D2 squared plus Dn squared. I mean, it's probably bad to use the same n there and there. It's 50. We also know that D1 less than D2 less than D3 less than D. Why am I? Like, I don't know if we get anything that meaningful out of this, but. I mean, is this in theory? I guess it's not, these aren't equations. They would. Okay. I guess we can. Yeah, so we can definitely throw out 8 and 9 as possibilities. Find out how much to add to 50. It's small if you can just like do it manually. Okay, yeah. So like if we go from the biggest digit first, like we have a 7 squared, that's 49, so the other digit must be 1. If we then start with a 6 squared, that's 36, and what is that? We 24. So anything after this has to add to 24, and so I think it's 3 squared plus. What was being put in chat? 1, 2, 3, 6. Oh, it's 14. You're right. That's 9. So then we have to make 5. So plus 2 squared plus 1 squared. Yeah, so that's each digit is larger than the one that's left. 1, 2, 3, 6. So that's a valid one. I don't think there's anything else you can do with 6. So if you have a 5 squared, you can do, well, no, you can't do another 5 squared. But you could do 16 plus 9. Should be 5, 4, 3. Oh, 3, 4, 5. Yeah. Is there Don does math but not pre-algebra? Oh my god. Yeah, I was hoping for a more systematic way of doing this than just figuring out the possibilities, but the problem is small enough that you can just do it manually like this, I guess. And if we start with a 4 squared, do we even get close enough? Because the most we can have is 4 squared. So the best we could do, no, because if we did plus 3 squared plus 2 squared plus 1 squared, we wouldn't get 50 because that's a 6 squared. So I think these are your only 3 possibilities that I can find. Because 8 and 9 are right out. They put you right over the 50. So out of these 3 possibilities, the second one is the most, or is the highest one there. One, two, three, four, you're saying works? Oh, you're saying, okay, that's the second reason why you can instantly eliminate without having to like think any harder. I mean, yeah, I eliminated based on the first condition, but the second condition also works. 36, nice. Okay, well, Jed and Fenbox both got there way quicker than I did, but... Took so long to get the wrong answer, don't worry. It's a weird, like, these types of problems are not easy for me. What about 3, 4, 5? Well, it's not the largest integer that has that property. GCH number is no smaller than the one on the left. Well, don't you just reverse the order? So 6, 3, 2, 1? Just going for a second, miss how you solve this. There's not a real trick to it that I saw, that I see, Momo. It's just, it's a small enough number that you can find all the possibilities. Each number is no smaller. Oh, you mean they could be equal? That I misinterpreted what you said then. Yeah, Momo, I just kind of, I started with the highest integers first as the first one, so 8 and 9 are right out because their squares put you over 50. If you start with a 7 squared, you're forced to only take a 1 squared to make 50, so you get 17. If you start with a 6 squared, your only option that I can find is 3, 2, 1 after that, so that gives you 1, 2, 3, 6. If you start with a 5 squared, you get 5, 4, 3, or, you know, it gives you 3, 4, 5 as the actual number. And if you start with a 4 squared or down below, you can't make enough, or you can't make a high enough number. Oh, it is an I don't know how you pronounce it. Alchemist? Question? Yeah. The solution is to add things together goodly. Okay. I think we did it goodly enough then. Oh god, what Zoom level is my Discord on? Maybe it's not Zoom. It still feels weird. Is that Zoom? No. I don't know. Put it there. Now this feels, I think it was that. No, dude, this is bothering me. I can't tell if I had this Zoom or that Zoom, and it's bothering me. I think it was this Zoom. It really doesn't matter, but like it bothers me. Alchemist or alchemist. Okay. Bob. Yeah, that crossed my mind, but then I realized it wouldn't work because of that. Said the 51s. Or why not have infinitely many zeros? I'm sure that's how math works. Then add a 0 to the end. Oh, it's true, yeah. I guess that's why that version of the question wouldn't quite work. I don't know. Okay, so I'm looking at part D here. Explain why the previous results imply the following statement. The charge big Q is externally located at distance A greater than R from the center of a grounded conducting spherical shell with radius R. There's a lot of nouns in this to keep track of. Oh, this entire thing is one sentence, by the way. There is a semicolon to be fair, but... Wait, no. This entire thing is one sentence. If a charge big Q is externally located at distance A greater than the radius of the spherical shell. Grounded conducting spherical shell with radius R. Then the external field due to the shell is the same as the field. So is all the Bob's monthly chatting. All right, see you next month, Bob. Thanks for stopping by. Alchemist pre-algebra is fun. I've been learning how to do arithmetic, though some of the official solutions aren't the shortest / fastest way to do it. Oh, okay. The alchemists with the solutions just aren't top quality a lot of the time. Oh, that sucks. To be fair, I think making questions like that is really hard. It can be harder than like, or I think it's harder than solving the question, usually. I haven't actually gone to it myself. I think it's just a website that gives you... okay, it's an art of problem solving thing, I guess. I think it just gives you like interesting questions to like work through. From the Orthogonal Khan Academy. Oh, nice. Nicholas Sandoval over on YouTube. Hey, could you help me with this Algebra 2 concept? It is transformations of linear and absolute value functions. The transformation I need help with is the vertical stretch and the horizontal stretch. Okay, so you're doing vertical and horizontal stretches for linear functions and absolute value functions. So I could try and talk about them a little bit, Nicholas. Do you have a specific like type of question that you've been working on though? It might help to have like an example here. While I'm at it, let me look up function transformations, because these rules always trip me up a little bit, because they're sometimes a little bit backwards. Let me find one. Okay, thank you. This graphic is really not clear to me. Is this the original? What the hell? We have y equals x squared. Then we stick a 0.35. Well, let's assume it's everyone. There we go. Okay, yeah. F of x equals 2x plus 6, vertical shrink by a factor of 1/2. Okay. So basically, if we want to vertically shrink it by a factor of 1/2, we want to take the entire function, ignore this stuff up here. Two x plus 6, vertical shrink by a factor of 1/2. If you are doing something vertically, I believe you take the entire function and multiply it by what your factor is. So we're going to do 1/2 times 2x plus 6. And so we could distribute in the 1/2 and do this stuff. See, these rules I always get a little mixed in my head, so like I do want to confirm this with like a graphing tool. But I believe the rule is that if you want to do a vertical shrink or a vertical stretch by say 2, you can just take whatever number they give you and multiply it in front, is my understanding. So make sure to use the entire function in parentheses and then your factor, so you get 4x plus 6. I think things get flipped though for horizontal. And how you do it is slightly different. So if you have a horizontal, wherever you see x, you need to plug in, I think the flip, actually, I really want to go to graphing calculator now, but I believe you need to take this, flip it, and then plug it in only wherever you see an x. So there's an x there, so I'm going to flip 1/2 to get 2, and do 2x plus 6. And that'll give you 4x plus 6. And a similar thing will be true for if you stretch it, you would also flip it and do that same type of substitution. But this is like, I always get tripped up when I do stuff like this, because just the rules are a little bit weird for me to remember. So let's actually plug what you're giving me into Desmos here. So this green line is the original function. So the first thing that I said was we want to do the exact thing that you gave, which is a vertical shrink by a factor of 1/2. So I did 1/2 times 2x plus 6, which, that feels weird. How is a line supposed to, I guess that, I think that makes sense, because I'm imagining a vertical shrink as you know, if this was the line that we started with, y equals 2x plus 6, and we shrink it vertically, I imagine it's almost like we're making it flatter. So like we take the line like this and we kind of like tilt it to make it flatter. I think that's what a vertical shrink is kind of doing visually. And a vertical stretch, I think, would tilt it to make it like steeper, almost until it's vertical. I hope I'm imagining this right. Yeah, like decreasing the slope. So if we do the horizontal shrink, I said we would flip it and plug only in for x. And so yeah, I think it makes sense that this is getting taller. Because we're taking the function and oops. I think a horizontal shrink would be like going at it from the sides and like pushing it inward until it's almost like vertical. Well, because this is always like a weird thing that I just like have a hard time like remembering. So let me just see if I can get like an actual like thing that would like confirm that too. Wow, there's a lot going on in this graph here. Okay, but this first part is talking about m is the vertical stretch. If you just have f of x equals m times x, where m is your slope, then m is your vertical stretch or compression. And it compresses the graph if it's less than 1. So vertical compression makes it flatter because we started with f of x equals x, that light blue line, and went down here to the red line. Okay. So yeah, that vertical compression does make it flatter, and the vertical stretch makes it taller because we go from f of x equals x to f of x equals 2x, and that's like, or it's steeper, not taller. Vertical shift. Oh, hey. I wonder... No, okay. So yeah, things get a little bit like weirder when you have like mx plus b, like that plus 6 was kind of like weirding me out, but I think it's pretty like procedural on how you kind of plug things in. Oh, okay. See, this website is doing something weird. And I don't know if it's right or wrong. shoot. So this website is saying that if you do have a function like mx plus b, you take the entire function times a and then you multiply it by a again? Or is that a period? Oh, wait, that's a period. Okay. No, okay, so I still did it right. Okay, that looked like a multiplication right there to me, but I think it's a period that just got formatted weird. So, Nicholas, I'm sorry that I'm being so kind of like wishy-washy about this, but it looks like this website agrees with me. Like a couple of sites that I've looked at agree with me, so I'm pretty confident that what I said to you is right here. With the caveat that this is like obviously like trips me up. So I even dropped a link to this in chat here because it's kind of, I think, relevant here. But Gabriela Baptista Arabola, can you solve an equation for me? Yeah, I mean, it depends on the equation, but I probably can. It depends on the class you're in too, but feel free to type out there in chat or put it in my Discord. Yeah, no worries, Nicholas. Just kind of happen to choose like the one thing that like tends to get me with like algebra, but I'm normally able to answer this stuff like that a lot more confidently. Let's erase what's on the board. Okay. Let me get rid of this ping that I have on Discord. Oh my god, there's like a million messages. Okay. Now I'm good. Okay, so as soon as I see Gabrielle's question, we'll switch over. But in the meantime, let's go back to the physics. Okay, so if a charge Q is externally located at a distance a greater than r from the center of a grounded conducting spherical shell with radius r, then the external field due to the shell is the same as the field of an image point charge minus Q equals minus QR over A located distance. It does? The total external field is the sum of this field plus the field from Q. The internal field is 0 by the uniqueness theorem. If a charge q is externally located at a distance a greater than r, wait, I must have done something wrong for part B or C, right? The radius I said was just 0. I guess that's technically in terms of small a and big A, but I want to check out. Was there a potential error in how this thing was entered? Let me. I'm going to check the answer just for part A here. I want to see if we have the right equation for this circle. Wait. What's B and C? Maybe they're not saying what B and C are to skip over the tedious work of dealing with these coefficients. Okay, what's the answer for part B? That seems pretty similar to what we have. Or not? Why is this so much simpler? Well, wait. What? So something's up here. Was there maybe an error in how this thing was entered? Which is pretty understandable. I don't actually understand how to read this. Did I set up the right equation down here? Minus a squared. They divide out the k's, which is fine. So if I wonder if Wolfram Alpha is going to understand what I want it to do here. If it's going to know that this is a constant, in that I want it to big A. Okay, well, it's solving it explicitly for y, which is fair, but not necessarily what I wanted. Hmm. Hey, exciting electronic shorts. 2 plus 2, I think it's 4, but don't quote me. It's 5? Oh yeah, that's my bad. Subs? Oh, well, thank you. I appreciate it. How stream like normally works is I take like homework questions from people in chat. And if things are slow and there isn't a question like there's now, I just do some like self-studying. So right now I'm looking at some physics. And I thought I got the right answer to a problem, but I'm checking against the answer key here. It's for part of this question, and I'm finding that something went wrong. This is a nicer way of writing it that they've gotten, though. I think. Coefficient of x is 0. Like, of this x? Why would it be that x in particular, and not both the x's at the same time? Oh, yeah, okay. I see why now. Um, q squared a. Wait. Big Q squared a minus small q squared big A over q squared minus q squared. So actually, this does match what Cook got, I think. I don't know if the radius matches. I don't think it does, for some reason. Yeah, critical. I was waiting to see if you would, or if you're gonna be here today. Although I, I guess I'm a little confused because we already did this one, and the other one I didn't look at, I don't think. This one I don't think we did, but... Setting some linear algebra today too. Oh, nice. Oh wait, no, we didn't do 11. It's similar. You're right. This part of linear algebra I never even learned in the first place. Maybe I can Google it or someone in chat will know how to do it. For 11, I'll tell you what I would do. It's gonna be a lot of work to actually solve the entire thing though. But if you want to show it's orthogonal, that's just the thing where you take all the possible dot products and hope they equal 0. So you do like u1 dot u2 is 1 times minus 1 plus 0 times 4 plus 1 times 1. Negative 1 plus 1 is 0. So, and then you do that for the other two possible combinations and show that they're all 0 for the orthogonal bit. And then for x as a linear combination, it means that we can set up that we can start by setting up the linear combination of u's, which are each of the u vectors times a constant. C2. 2, 1 minus 2. And then we're expressing x as this linear combination, so there's an equal sign, and it equals x. 8 minus 4 minus 3. And then you can make a matrix equation out of this. That's completely equivalent. And then you can make an augmented matrix out of this. And so with this, I would just do row reductions until you get the identity in there, and then that's your solution. But doing every part of the problem is going to, I think, be a lot of calculations that you already know how to do. I can plug in a tool from Alpha if you just want to see the final answer, but I just would rather not do that entire thing by hand. P2 is a set of all polynomials with degree at most 2. Okay. Oh. Do you just take a linear combination of these three things and set it equal to this, and then do the equating coefficients? Okay. So there is at least partially wrong anyway. Why isn't that erasing? I even cleaned this eraser. It's probably the marker that's going bad. And I'm going to keep on using it. Okay, so we're going to take all the B vectors and do a linear combination. And we're setting equal to P of t, which is 3 plus t minus 6t squared. Okay. That plus looks like a t. All my pluses look like t's, to be fair. And so we solve this by equating coefficients. We know that anything multiplying the t squareds has to equal whatever's multiplying this t squared. So we have a c2 multiplying that t squared and a c3 multiplying that t squared. So we know that c2 plus c3 from those and those times those must equal minus 6. Anything multiplying the t's must equal 1. But we have a c1 multiplying a t, and we have a c3 multiplying a t is equal to 1. Then the constant 3, well, we have a c1 times a constant, and a c2 times a constant equals 3. Now we have 3 equations and 3 unknowns, so we can just solve for c1, c2, c3. It's kind of all the same what we do here. I'm going to take these last, well, yeah, I'll take the last 2 equations, just subtract them, because I see we can do c1 minus c1 is 0. Subtract, those go to 0. We get c3 minus c2 equals negative 2. Now we can use that equation and that equation to solve for c2 and c3. Equals negative 6, and I'm going to take this one and just swap these two. Oh! Suna, thank you very much for the raid. How's your stream? I hope it went well. So we're on some linear algebra right now from Critical. So I took this equation, I copied it, and then I'm going to take this equation and just swap the c1 and c2, the order of them. So minus c2 plus c3 equals minus 2. Let's add these to get rid of the c2s, I guess. So we get 2 times c3 equals negative 8. So divided by 2, you get c3 is negative 4. Now we can choose either of these equations to plug back into with c3. I'll just choose that one because why not? Minus c2 plus negative 4 is negative 2. You add 4 over to get positive 2, multiply by negative 1 to get negative 2. Yeah, so c2 is negative 2, c3 is negative 4. We only need c1 now, so I'll use that equation. c1 plus negative 2, which was c2, is equal to 3. So c1 is 5. So I think your coordinate vector is going to be 5, negative 2, negative 4. Wait, oh, okay. Can we get to the end? Was it actually solving for the C1, C2, and C3, or what was the issue? Oops. Oh yeah, I did it mentally, but there is kind of a more proper way to like show it, or at least like there's a clearer way to show it. That involves a lot more writing, which is why I didn't do it, but you could multiply the C1 in there, the C2 in there, and the C3 in there to really show why these equations work. And then, yeah, you can group the constants with the constants, the linears with the linears, the squareds with the squareds. And in this form, it's a lot more clear why, or why this equating thing actually works. Because you know that this chunk has to equal that chunk, this chunk has to equal that chunk, and that chunk has to equal that chunk. Yeah, it's just a trick called equating coefficients. But yeah, that's how you do it basically. And soon I hope the stream went well. If you just want to like get out of here and get some rest, if you haven't already, then please do. No worries. Should maybe clean off the whiteboard. It's annoying that black is leaving streaks. Negative plasma. So it seems using a lot of rules of algebra to solve this. Yeah. I'd say that one is pretty algebra heavy because you have to distribute everything and rearrange it. You have to equate coefficients, and you have to solve a system of three equations with three unknowns. So there's a good bit of algebra in that problem. I think number problem 7 is easy. I don't know the interpretation of the concept underlying problem 7, but it kind of comes down to doing pretty normal algebra kind of techniques. So for me, doing the actual algebra wasn't that hard at all. But yeah, I mean, if you're not comfortable with like, especially the equating the coefficient thing, it's normal to like struggle with it. I've just had to equate coefficients in other contexts a bunch of times, so I'm used to it. Because algebra rules. Hey, megalomorph. It's my favorite geometer. Non-commutative geometry is actually algebra. Oh god. What is commutative or non-commutative? Like, I didn't know that commutativity was a concept in geometry. Does that mean that you could swap the points and get the same thing, or I don't know what the commutativity means. Commutative geometry. Or non-commutative. Geometric approach to non-commutative algebras. Oh, okay. Sure. Yes, that is math. Algebraic geometry studies geometric things. Looking at the ring of functions on the spaces, which are commutative algebras. Commutative has both space and non-commutative rings of functions. Okay, I've heard the term algebraic geometry before. And the only thing that I know about is that it only deals like things that have symmetries, I think is what I've heard about it, but non-commutativity, yes. Okay. Yeah, that's where my understanding of like what math even is or does really like breaks down. Critical what math is this? Since the math is beyond my comprehension. Yeah, I mean, if you talk about that non-commutative geometry thing, I'm right there with you. I know extremely little about any of this. If you're asking about the math that's right here, it's part of the physics that I've been doing. It's the answer key for a problem I've been working on, and I'm looking at only the first part of it. Type of math that emerged from a drunk discussion between mathematicians. I would believe it. I bet a fair bit of math has been done that way. Direct slowly branching into quantum optics and communication is nothing but wave functions and integrals. I mean, that sounds cool. Starting point of algebraic geometry is looking at the spaces where a collection of polynomials all vanish. Huh. And studies how the geometric properties of the space can be studied from the algebraic properties of the defining polynomials and vice versa, but it gets much deeper. Yeah, even there, it's like I can kind of imagine like that in your example, y minus x squared vanishing gives a parabola means that y is like approaching x squared or something like that. But even then, like the geometric properties of the space, I don't know what those would be, and you don't have to like sit here and explain all of it to me. It's just like a I feel like I just don't really have the foundation to really like understand why it's important, I guess. So, you know, I'm only like very slowly working my way just through like basic group theory right now. It's part of Penn Center's abstract algebra group. which I read the very first part of like chapter 5 or 6. I think particularly starting on the one after that. Oh. I don't know. So what was I trying to figure out with this? We have B is this thing divided by this thing, which I think did match what Cook said, which is that right there. Why does the radius not match? That's what's kind of weirding me out. Oh, because the radius is actually this, c plus b squared, and that's just c. So maybe what Cook did is right. Okay. Yeah, that must be why. I shouldn't embrace it. But why do I get the wrong answer for this part then? See like what the dimension of the object is or whether it is smooth, what its sub-objects are. Modern algebraic geometry uses tons of more advanced abstract algebra, so I have to do full use of abstract algebra, then there's commutative algebra, then algebraic. Oh, okay. So it's some differential topology and algebraic topology. Oh, geez. I'd be okay if I missed out on those classes. Just give me some differential equations. So, like, oh, was I thinking about it wrong? Oh my god. It is the same thing, but did I mistakenly factor out the A's? And I shouldn't have? I guess that was my issue. Okay. Well, I shouldn't doubt Dr. Cook. That's the lesson here. Once you have algebraic geometry and a few more advanced things, you can study differential equations by means of something called D modules. Oh, great. Ugh. Yeah, so the real answer for part B is that big A small q squared must equal small a big Q squared. On board with that now. What was the thing that I just said? Yeah. Like a little more. Oh, I doubt it makes anything easier. Yeah, I would imagine it just makes it more complicated. Or at least the amount of foundation that you'd have to, or the amount of time you'd have to spend studying to learn the foundations would be way harder than just learning the method to solve it. I would imagine it's trying to make generalizations about differential equations. talk about like many different types of equations at the same time. Usually when the word algebra is involved, that's what they're trying to do. Trying to like unite things. It's like you might be able to say, you may be able to make some statement about like differential equations for like any order or something like that. Hey, Scorpra. Wow, that is a hell of an emote. I guess, yeah, I mean, Twitch approved it. Hope you're doing well, Scorp. What is the radius of the circle in terms of A? I regret erasing. I want to rewrite the equation for the circle. Well, we can just, we know the radius is this thing here. We can just, doing well, it's good to hear. So we're trying to understand differential equations geometrically by looking at things like the ring of differential operators and the sheaf of local solutions. Differential equations, not only your fields, may be completely wrong. I'm just going to agree. So the radius of the circle is minus a plus a q, which this is really terrible to, do verbally because, we have small a and big A and small q and big Q. But I'm doing it. That's the radius of the circle. Negative plasma. Ugh. Thank you for the bits to enlarge that emote. It is a pretty great emote. And if we let this thing here be true, this probably is not valid notation, or it's not common notation at least, but I'm going to do it. Well, actually, I don't even want to let that be true yet. I want to distribute in that QQ. Which whenever I say QQ, I think of like capital Q, which is like a crying face. And that's kind of appropriate for how these physics problems make me feel. Minus a QQ plus big A QQ. Q squared minus Q squared. And then we'll let the relation from part B hold. That's a small q, I promise. Yeah, the geometric perspective is always nice, but I don't imagine that anything about whenever algebra is involved, I'm usually lost. What does this mean? For some reason, I thought we would get like a q squared and a q squared, or something that would actually be directly applicable here. I think we'd have to multiply it by big A small a over big A small a to get anything helpful. And let's just pretend that that equals, I guess, B. Well, we don't even have to do that. So we can take that out, that AQ squared, and we end up with just that A, and then this, we would pull out that AQ squared, end up with that A. You say QQ, something make the laser gun noises. QQ, QQ. Yeah. Maybe I am. Oh, we get a cancellation up here, don't we? So really, I should never have multiplied in that QQ. QQ. So we get QQ. That A cancels with that A, so we get a small a over Q squared, which is Q over Q times A. So the big A goes away entirely. But if I had taken the other substitution, the other A would have gone away, right? Like if I had made this small a Q squared, which I could have, we would have gotten the big A there. So what is that? I think that would mean that we could also say that's equal to that. Would that mean that big A equals small a? Check the answer for this one too. So that's part C. Oh, you're kidding me. What? Oh, I'm working with R squared in this entire thing. I did miss out on that. Q squared A squared. Wait, the thing that I started with is just different. That's the problem. Ugh. But wait, you can't just take this and divide by Q squared minus Q squared and say that this thing is the radius. You still have to complete the square over here. What? Q squared A squared minus Q squared A squared. Isn't this just wrong? They even say the radius is C plus B squared. They just said it's equal to C though in part C. This can't be right. Hmm. I wonder. Okay. The electricity and the magnetism. So in Morin. Problem 3.13. Like, is there a mistake here? Hey, Tay. How's your day going? Hmm. It's going good too. Thanks for asking. I feel like I found it's either I don't understand the answer key for this problem or they made a mistake because I feel like something weird is happening. I feel like I'm going crazy, but um, I think it's a different problem. Okay, fine. You know what? I'm just gonna move on from this problem. So I feel like it's wrong. I guess I need to maybe think about it more. Um, you know what? There was Penn Center's final that I could work through. Just for funsies. Although I feel like I don't know if I'm gonna be able to do this last half here. I'll just try it. All right, so this is the final for Penn Center's like complex variables class. Try your E&M midterm. I can do that too. Was that in the group chat? There it is. And you took out all the identifying information here. Okay, yeah. Looks like it. Oh, I see a flat disk. Is that gonna be Coulomb's law? I don't know. Oh, actually, no, it's gonna be a little bit more. That's like pretty far on in the thing. Hot take. That sounds wrong. It is the real Don does math. Oh my god. Dude, I have to show the clip. It was really funny. Yesterday I was playing Daisy, and I raided a friend of mine who's playing Deadfall, and then he raided Fish, and when Fish saw my name, she did this little like song that like cracked me up. Wait for it. Like, time to get on the meth account is what like gets me. Like, Stream like going live song, yeah. Time to get on the meth account. Me special nickname for you, like I have for Donkey and Hardlocked. What I know you call Hardlocked Hot Dog. What do you call Donkey? Blinky? Oh, that's right. I remember that now. See, it's a slow. I mean, I do stutter. What would be a good nickname for like a stuttering person though? I don't know. I can't give myself my own nickname though. I have to leave that up to you. I feel like a Strutter. I love your stutter. It's my favorite. Oh, hey. Yeah, my stutter was way worse when I was younger. Now it's at least like mostly if I'm like nervous or have too many things to think about at once. Like if I'm in like a gunfight in Daisy, I'll stutter all the time. But if I'm just like chilling, I'm usually good. Double talk Dom. A non-conducting sphere is given a non-zero net electric charge plus Q, non-conducting sphere, and then brought close to a neutral conducting sphere the same radius. Which of the following will be true? So the type of thing is, yeah, that's true. Can we Dom? I love using studying for community effect. Other than just come on, man. I mean, it's definitely funny in Rick and Morty when Rick stutters, but which field will be induced within the conducting sphere? I don't think it'll be within the conducting sphere, so it shouldn't be because the potential is constant. Material will develop a net electric charge of minus Q. Well, that's not true either. It's net neutral. The spheres will experience an electrostatic attraction. That seems true. The spheres will experience an electrostatic repulsion. That's not true. The spheres will experience no electrostatic interaction. That's not true. I think it's C for part 1 here, problem 1. It's like place emphasis on the word. It's like poetry. Every time I stutter now, it's going to be my excuse. I'm doing it intentionally because I want to emphasize it. Because history repeats itself. Ugh. I mean, that's a little bit of a stretch, though. Because, like, when you stutter, you're not repeating yourself. If it was like, in Goodfellas, when they have, Thank you, Hardlocked, for the 110. Oh, sure. I shouldn't be paying attention to how loud that is. I feel like it can maybe be a little bit louder. Let me replay it and look at the audio level. Gonna get 2 for the price of 1 here. Oh, that could be louder. Let's turn that baby up. You want it to be ear-shattering? How the hell do I... Dashboard. It repeats some self-history now. But yeah, what I was thinking is that it's like in Goodfellas, his name was like Johnny 2 times or Jimmy 2 times. He said everything twice. That's what I think of, like history repeating itself, like that nickname. Okay, tip alert. You know, I'll just like show this too, because why the hell not? What was it, 110? Really bump that baby up. But we have to go over to the bits and do the same thing, because stream alerts is kind of stupid with how, if you have a lot of alerts like I do, at least. Okay, put it all the way up, save it, back out, and now let's replay it. That's barely louder. Huh. Really bump that baby. I mean, yeah, if I could go past 100, I would. I would have to go back to, I still have the original clip. I could just make it louder in the source clip. That's really annoying. I can't go above 100. Just look at it again. Yeah. That one feels like it just needs to be louder. It's gonna be too annoying to do on stream here, but I'll make a note to myself and do it off stream. It's not that hard. I just need to normalize the audio to a higher level. Play it on a speaker in your room? Oh my god, that would be a jump scare right there. Make scream sound alert louder. Okay, I have a note to myself. Yeah, I mean, I try to not have a lot of jumps. Like, I feel like that one is just like generally quiet for what's happening in the clip, but like, I'm not a fan of like actual jump scare alerts, because if I'm watching someone stream, I don't like getting jump scared by their alerts. But that one does need to be louder. So yeah, for problem 1, I'm saying the answer is C. It'd be good to keep track of this somewhere. Yeah, I'm too lazy. It's gonna be too annoying to like take screenshots or something, or be able to draw on this. A ball of radius r has charge non-uniformly distributed throughout its volume. One streamer used to watch had metal pipe falling MP4. Like that was an alert? That sounds so annoying. But no, like some streamers have like a super loud like bang that'll suddenly play, and if I'm just watching a stream, I just want to chill. I don't want to get jump scared by their alerts. So that's why I don't like being too extra with my alerts. The day someone played a jump scare in someone's stream, it scared the crap out of Asia. It was so... Yeah, exactly. That's what I don't want. Like, it's funny to see the streamer freak out, but I don't want to freak out myself. 500 channel points? Oh, God. You don't have to pay for it. LRSR is charged non-uniformly distributed throughout its volume according to the radially varying volume charge density rho of R. The Gaussian sphere of radius r less than r is used to calculate the electric field strength E at distance r from the center of the ball. Which of the following equations is results from a which of the following equation results from a correct application of Gauss's law in this scenario? Well, C and E are definitely right out. We don't want big R. We want small r for the actual smaller radius that we're actually enclosing. And oh, this one, you can really game this one, I feel like just like psychologically. You just know it's not going to be the 0. And then you also have a 50-50 between 0 to big R and 0 to small r for your bounds. Like, you can just like narrow it down to B and C. Shelby lurky lurkin? Sounds good. Thanks for the lurky lurk. Hope you have a great night too. I'm probably going for another hour or two-ish. Oh wait. Oh, it's just B. Yeah. I thought there'd be a harder choice between B and C, but I forgot. I already threw C out. You're betting on F? That's a good bet, Waffle. Cook, I mean, if you don't mind, yeah. So problem 2, I think I'm saying B, final answer. B is right? Okay. And problem 1, I was saying C is correct. Actually, can I? Wait, is it easy to draw on this? This looks like that's a highlight? That's a text? That's a draw. Ooh, we can draw. Give me, I guess, red? Oh, wait, no. Do you agree with C for 1? Okay. Actually, okay, I was gonna get my, like, DDM blue, but I'm too lazy. I'm just gonna... Let's just do red. So C, B... Until is actually get like the hex code. The diagram below shows equipotential lines produced by an unknown charge distribution. A, B, C, D, and E are points in the plane. Okay. At which, okay, 3 is what I was just trying to figure out in my head. At which point does the electric field have the greatest magnitude? So it's changing by a constant amount, and E is the rate of change of phi, the negative rate of change of phi. So that's not a trick question, though. E isn't constant. Or wait, what at which point does electric field have the greatest magnitude? A, B, C, D, or E? Well, it can't be both A and, or it can't be A but not B, or B but not A. So I think we can take those two out just like logically, I think. I feel like the greatest magnitude. Which would lead me to think E. Said with that exact tone. Because higher potential should imply higher field. Well, Because out at infinity, it's zero potential, depending on where we're... Well, I mean, I guess it's zero potential wherever this is. I feel like the field is constant if it's changing by 5 each time. Am I getting it backwards? E is minus del phi. Oh, wait. Should it be where these lines are the closest? This is a closed book exam? My bad. So that would be B. That's so weird. Is it because there could be a negative charge? Or I guess we're just, it doesn't matter? Hmm. Where the hill is the steepest. Okay, fine. It's B and I definitely didn't cheat. Okay, I guess that makes sense. It's still confusing to me. I guess it's not a... I'm too used to, I guess, radially symmetric fields, and this isn't a radially symmetric field. It's still weird. I guess... Oh, we're only drawing it in increments of 5, but that doesn't mean that it's a constant rate. Okay, yeah. That was the error in my logic. Okay. B is correct? Okay. All right, and then 4 is related to the same figure. How much work does the field do on a minus... Think of the equipotentials as lines of equal height on a topographical map. Lines of equal heights. Yes, okay, yeah. Hey, Zach. How's it going? We're doing, just for a little bit of like downtime stuff, this is an E&M midterm that Dr. Cook made for some class that he taught that he kind of like scrubbed for personal information. We're just kind of working through it for fun here. Like an elevated plateau, it's in the bottom right of the figure. So like, in our gravitational analogy. Oh my god. What is the infimum of lol? Doing well, that's good to hear. Well, I mean, isn't there a plateau here? Bottom left rather than bottom right? Or wait. Can I? Okay, I'm able to undo. You said like there's a plateau there? I mean, I feel like we just don't have information like down there. Or do you mean like... Well, no, I don't know. I have a really hard time interpreting this, I guess. Or interpreting like that analogy. Charge the field doing a -2 microcoulomb point charge. So from the point C to the point E at a constant speed. Last seen 16 years ago on YouTube asks 4 to the x equals x to the 64. Find x. Oh god. Someone asked me a question just like that last week and I didn't know how to do it. I don't think I know how to do this one either. Is there supposed to be a trick for doing those? Like, I know you can take the log of each side, but you still get something that's hard to evaluate, don't you? $256 apparently. Oh, that's right. You guess powers of 2. All right, yeah, last seen 16 years ago. I'm just going to link you to this because... What? That's not... There. I think this is the technique for a problem like that, and I'm really not that good with those. How do I not select you? Okay, like that, I guess. Yes, Zach, it would be... Wait. How much work? Well, no. How much work does the field do on a -2 volts? The volts times the charge is the potential energy, or which is the same as the work done. From C to E. From C to E. So we moved over a difference of 10 volts. So by my logic, it would be -2 times 10 is -20 microjoules. I think because it's a negative charge, the potential is for a positive charge. So I think I'm comfortable with the... Well, it depends what direction. We're going from low potential to high potential. So I think it should be a negative answer, yeah, because we have negative charge. Yeah, work is force over distance, but the volts are already work. So I don't think we necessarily need an integral. Hey, Lucas? Oh god. There's a lot of vowels and S's in there. I'm just gonna say Lucas. Welcome in. How are you? I'm doing good. Hey, thank you for asking. The field wants to move positive charges downhill. Right, but we have a negative charge, so it wants to move uphill. So I think I'm going with B, personally. Doing good as well. That's good to hear. Just I see you're a first-time chatter. Feel pretty done the last 2 days, so you're gonna do some maths? Okay, nice. Yeah, the theme of my stream is that I take homework questions. It's C. Oh my god. Why is it C? You have to flip the sign? Okay, fine. I'll mark myself wrong. But yeah, the thing with my stream is I do like math homework help, and during the downtime like there is now, I'll just do some self-studying. So I'm working through a midterm for any electricity medicine class that Dr. Cook taught. Just kind of for studying purposes. Field wants to move the negative charge uphill. So because the field wants to do it, it's positive work. Oh, by the field! I was wondering about that phrasing, like... Okay. I activated your trap card. And it's more problem of not concentrating thing than actually being able to not remember it. Oh, okay. Oh yeah, I would do that too, Zach. I mean, that'd be kind of cool to have, like, make a composition around that or something. Yeah, Lucas, if you're, I'm not the only math streamer in town, so if you're interested in more math streamers, there's a whole list of them there, including E2Pi is right here in chat. Everyone on the list does math help in some form, as well as Dr. Cook in chat has been streaming too. Yeah, the list has been getting longer, which I think is a good thing, but the only kind of like, and you don't have to like do anything you don't want to do. I just like to advertise that there's a whole little community of us out there. Oh yeah, and Waffle's been streaming as well. But I just like to let people know that, like, I'm not the only, like, the only one here. So yeah, that's fair. No, yeah, please do. Like, you don't have to. I'm not asking you to go and hit follow like 10 different people all at once because I'm telling you to, but I just like to let people know that there's a whole, like, really cool niche of people here. And if you like my stream, or even if you don't, you should, you know, give the other streamers a watch at some point too, and see if you like them. But obviously, you do whatever the heck you want. And also, hi Scrimp, I saw you. It looks like you didn't fall for the trap either. We the people demand a solution to the Riemann hypothesis. Are the solution to the problem 4 involves the Riemann hypothesis? Yeah, probably. Gone dark since your OnlyFans really started taking off. OF is OnlyFans, $10. Well, you know, best of luck with your OnlyFans. Your math's around the level of a year 4. Year 4 in middle school. Oh dang. Well, I mean, none of us like that's completely fine. Like, you don't have. I'm doing some, like, pretty difficult physics, and I often like to do some difficult, like, math stuff, but like there's no such thing as like a math problem that's like too easy for me. So if you ever do have a question, there's nothing that's like that's too basic. 16-year-old class, 16-year-old is in. Oh, okay. So that's like a sophomore or so in, like, American high school terms. Or a junior, something like that. Sophomore is year 3 in high school. So usually, I think you're 15 or 16 if you're a sophomore, and you're 16 or 17. No, I might be off by a year. You're 16. Wait, a senior should be 17 or 18. A junior should be 16 or 17. A sophomore should be 15 or 16. Something like that. Want to try to answer questions of things you're particularly proud of. Oh, really? I mean, maybe we won't, like, solve it quite yet, but, like, which one is it? Out of curiosity. Two concentric spherical conductors. 5? Let's see. Oh gosh. Got a vector field for this one. About functions and the D and stuff. Also like logistics a bit. Huh. Like derivative? I'm not sure. D might be something else though. You feel a lot smarter than Purcell and Warren problems? Yeah. Okay, well, I'm curious to see what's up with 5, if you're, like, particularly proud of it. Well, let's just skip around and do 5 right now. Oh, discriminant. Okay, b squared minus 4ac. Nice. That does come up a lot. A non-conservative swirling electric field, which I think isn't realistically possible, but we can still, like, consider it. I think like that, like the curl of field has to be 0. Conceptual question, not too much calculation. Note that E of xy is 0 only at the origin, increasing magnitude with increasing radial distance from the origin. Clearly draw and label the following directed paths on top of the vector field E below. A path L plus from A to B, along which E dot ds is greater than 0 everywhere. Ooh. So this is asking about doing positive work, negative work, or 0 work. Oh, wait. Not... This is agreeing with the field, though. So if we want E dot ds to be greater than 0, we'll do this first part in red. I think about, like, the cosine theta. If we want that cosine theta to be positive, they should be more or less in line with each other. Like, if we can't be more than 90 degrees off. We have to be, like, with this vector in particular, we have to be somewhere within... like that angle is how I'm interpreting this. So we should follow the swirl. I think for that one. How do I... Okay, what? I'm control Zing, but it's not going away. Okay, you know what? Who cares? We just have a red dot there now. That is our life. Oh, wait. Oh, that's going to delete the spiral, too? Oh, it's going to... Oh, my God. You are the worst PDF tool thing. Oh, okay. Directed path. Sure. My latest and also hardest theme was like x1 times 2 plus y1, y2. Oh, x1, x2 plus y1, y2 over x1 squared minus y1 squared. What would that be? I'm trying to match with something that I know. That's like some vector stuff, it seems like, almost. Actually, that's not quite. Well, like a dot product divided by something. I'm disturbing. It's just like the slope of a line. Oh, it is. My mind went to the right place. It's like if you took... Is it like if you took this thing and you solved it for cosine theta? Like, I don't know if this notation looks familiar, but it's this divided by this. Not that? Oh. You're trying to say you're nowhere near this level? There is the law of cosines, but that doesn't look like it matches. Oh wait, well, A dot B is like this. I think it might be. Maybe you didn't learn it with this exact notation, but I think it's something like this that you're talking about. Unlawful, this isn't like anything that crazy. Oh, that one. Okay, the law of cosines. Yeah. It's the law of cosines. Is there a vector interpretation of this? It feels like there is now that I look at it. These formulas feel really similar. Yeah. Using vectors. Yeah, I think I've seen you do some stuff with vectors. Waffle. I'm sorry if I'm misremembering that, but the dot product isn't too bad to use. Okay, nice. Yeah, I mean the stuff is important to know. Way too many formulas. Yeah. Sounds a little bit of funsies. Okay. Okay, we'll do... Oh, no! Oh, why do you do that to me, PDF tool? Give me a new color. Let's try that one. Delete that. Oh, I can't draw inside of... Oh my god. This is the worst tool I've seen in my life. Okay, we're gonna take a screenshot of this thing and put it into Paint. You literally can't even draw overlapping lines of different colors. There we go. I am pulling in Danny. So you need to know, I think it's a1.a2 equals -1. Oh yeah, that means they are pointing in exact opposite directions, I think. Oh, that's... Oh my god. Okay, the red swirl with the green. Green swirl. Oh wait, directed. I don't want to get it marked off a point by Cook. Against the grain for negative. And direct it. And then equals to 0. First, I really like puzzle games. That's why I also came into this math stream. I think that math has something to do with puzzles as well. Yeah, it definitely does. So if we want to do 0 work, we need to be perpendicular. To these fields at all points. And so I think that the easiest path that I see is to draw from A to the origin, and then from the origin to B. To do 0 work. Bonus points if you can make the 3 paths combine to a 30 picture. That'd be hilarious if you could do that. That's what you're thinking too? Okay. Yeah, I mean, if you can figure out a way to make a dirty picture with that, DM me too. I think he'll take off minus the size of an electron points for no arrows. The great puzzle game is Scrabble. Of course, Waffle. Now, Cook, if a student actually turned into you, so that made a dirty picture, like, as the professor, would you give extra points for that? Like, how would you react? That's funny, but I feel like it's maybe not proper to like comment on it. Click back on the tab, now you're seeing a field map. Yeah, sorry, Joseph. So you basically spent free time with chess. Yeah, chess is fun. A Rubik's Cube. Rubik's Cubes are fun too. Tetris I've hardly played, but that could be cool. It's gonna make your spirals a bit sharper. Yeah, I could have gone a lot steeper. Plus points for creativity. Which point in the field is at higher electric potential, A or B? Oh. I think this is a trick question. Ignore not professionalism? Okay, fair. Because it depends on what path you take, and that's what part A kind of teaches you. You're gonna go back soon? Awesome. Well, not awesome that you're leaving, but oh well. Thank you for the follow. Thanks so much for like popping in and saying hi. Oh no, that's the new alert. I hate stream elements. It just says I wish I was high. It's supposed to be I wish I was high on pot news. Oh my god. Stream elements is I hate the way they do alerts, but there's not an easier platform that I know to do what I do with alerts. So I'm really gonna fix that right now because it's gonna really bug me. Follower, a crackhead or something. Hey, I'm a meth head. I'm Don does meth, okay? Yeah, let's put it up to 3 seconds. Hit save. Let's test the alert. Okay, it played double because of the way I did it. But that'll be, like, that's fine. Then I also need to change it in this other place, too. I need to change it in 2 other places. Oh my god. Make it 3 seconds. Cheer alert. Variations. High on pot news. 3. Oh, you said the answer key? Okay, thank you. Okay, that alert should be fixed. Okay, you don't think it's a trick question though, Penblock says. Really? If it's independent of path, what are we defining to be the zero potential? A natural choice would be the origin, I guess. But from part A, like, we can find multiple different paths where E.ds has completely different signs or is 0. And so how do you find just one potential? Because even if we define the origin to be 0, I could go from the origin, like, way out, do a bunch of work out here, and then come back in. Or I could follow the spiral and do 0 work with this crazy path, and then come back in. Like, I don't think there's not a unique answer. which is why I'm saying I think it's a trick question. But I'm open to being corrected here. Like, the electric potential isn't defined if it's not path independent, I thought. The interesting thing has to do with the intensity of E. So it definitely gets more intense the farther away you are. But you have to, like, electric potential has to do with work. Or even just, I mean, we could even just say that potential is the integral of E dot ds. No, I'm saying it's a trick question. The spinny air circle is still here. Yeah. I mean, we're at the last part of it. If Cook sent the answer key, I assumed he might have had to go. I might take a peep at it for number 5. But like, I'm ready to lock in that this is a trick question, and that neither, or like we can't tell. You are here, okay. So my answer to part B here is that, I guess I could even type it out here. It is not possible to determine whether A or B is at higher electric potential because it is not, because they are the potential for this field is not independent of the path, not conservative. I think that's the answer that I would put if I was a student taking this test. I'll also determine whether A or B is at higher electric potential because the potential for this field is not independent of path. In part, I mean, we can even like go even more ham. We could find paths from A to B that yield positive potential, negative potential, and zero potential. And hi here, I'm waffle. The dad joke. All right, I'm gonna check the answer. Does Fenbox, are you okay if I talk about it, or do you want to think about it more? I don't want to spoil it for you. I'm looking at the answer. Oh, it has personal details. Okay. Don't spoil for anything. You almost have it. Oh, yeah, unlocked. It's close to 2. Okay, but this screenshot doesn't have anything personal on it. Let's pull that up. So yeah, these paths are a lot steeper, but they never cross over that perpendicular mark. So Don does leaks. Potential cannot. Hey, let's go. So yeah, Hardlocked, I think this is close to 2. You're completely right. Also, you should say. Non-conservative electric fields like this can be generated mainly by a changing... Oh, really? So I assume this is like purely theoretical. So you'll learn when you get to Faraday's law of induction. Okay. It's good to know. Because yeah, well, when they talk about the electric field being conservative in chapters 1 and 2, it's because it's electrostatics. Okay. But yeah, the same thing wouldn't hold for not electrostatics. Or whatever, okay. Well, so far I've only gotten one wrong, so it seems I am actually learning something so far. Four-point charges plus Q greater than 0 are arranged at the corners of a square. At the center C of the square, each charge produces the electric potential V naught relative to infinity and field strength E naught. Each one gives a net electric potential relative to infinity and field strength at C. Ooh, there's gonna be some cancellation happening. Oh, not perfectly canceling. Or are they? Let's go back to paint. I shouldn't have closed out of paint so quickly. So Q E naught V naught. So I assume it's safe to assume that as soon as we reach like this point here, we're at V naught potential, we don't have to also add up some like fraction of the V naughts from these other charges. And we want to get to C. Well, wait. Oh, wait, I did misread the question. E naught and V naught are at the center. I want to say that this feels a little bit weird. Each charge produces... Well, I think the field is going to be 0. Right in the middle. That doesn't mean we've done 0 work, though. Oh, God. So I think these field lines go something like that. Well, not from outside. Aventuras de Mellitos over on YouTube says, what is 1 times 1? It's 1. Welcome in. 5 times 5, 25. Ooh, well, that's actually one clean field line. How can you solve a Rubik's Cube? With a lot of memorization. I do know how, but it's a little too hard to just like explain on the spot here. Well, it's independent of path, so I'm going to make the claim off the bat that the field at the center is 0. Because I think everything is canceling there. And I'm going to say that just V naught, or sorry, they give EC as in VC as the center, like totals. The total field at the center is 0. The total potential at the center, I think, is V naught, because I could follow this path perfectly, like diagonally from that 1 point charge, and assuming that 1 point charge. Well, am I? From intent on how should predict the course of the pieces will take and find the best path to solve a Rubik's Cube. I have to know how you can do it in less than 20 seconds. Oh yeah, I definitely have done a Rubik's Cube in less than 20 seconds. I got very lucky though. V is a scalar. All right, bye. Okay, bye. Aventuras. I take back what I said. Because why do I take it back? So if I do follow this path that I put here, which might not even be the best idea, this one, oh my god, this one, we're always opposing. But I assume the coefficient for V naught includes that, like, if I do follow this path, this one here is contributing first positive work. Wait, no, I don't know. Sorry. I thought this green thing was a field line for some reason. I'm getting myself mixed up. Oops. Principle of superposition? Oh, it's 4V naught. Because if we take this path and we get V naught, we would add it to all the similar paths also through these corners? Huh. Okay. So that would mean D. No, not green. Get your green out of here. If one path doesn't go through the charges. Oh, is there... Why is that? Oh, well, I guess because of the asymptotic, like, I guess what you're saying with if we do it one at a time, I can choose any path I want and get V naught once I get to that point. Okay. Yeah, I guess, yeah, what you put earlier in chat, thinking about them one at a time is a better way to do it than what I was thinking. An isolated conducting sphere has radius r and is initially uncharged. Which of the following gives the total work done W external required by an external agent to increase the net charge in the sphere from 0 to Q, bringing the charge in from infinity? Um, okay, so I'm imagining that very first charge does 0 work because the conducting sphere is initially uncharged. And as soon as you bring in that first little piece of charge, that conducting sphere now has a net charge that we're now opposing and doing work against, so positive work. Which leads me to believe D. But wait. No. C, just over R. So yeah. I was getting mixed up because I was thinking we should integrate the field to get potential. But we're not doing that. We're integrating potential in a bunch of different scenarios to get the total potential. I think I'm locked in for C. Yeah, I'm saying C. It does concern me that 3 of these don't have integrals and 2 of them do have integrals. So if I'm doing my psychology trick, I mean, this one is kind of weak though. It's not always true, but I feel like usually it's the thing that has 3 options rather than has 2 options. Dimensional analysis. Oh yeah. I mean, that would eliminate A and D, I guess. Well, and E, yeah. it is a conducting sphere. Is that relevant? I don't think it is. Or I think it just means that we can consider it a point charge as we add charge to it. I think there's a pretty similar problem in Purcell and Morin, where they give you two potential values for the potential energy that are off by a factor of 2. Oh, mostly Maxi. Thank you so much for the raid. How's your stream? Yeah, for anyone on my end, you should go check out Maxi. I've seen her doing some Rust programming. Very nice, very chill. Awesome, awesome. Glad to hear it. We got a little bit of downtime where we don't have questions from chat, so we're working through an ELHC in magnetism midterm that Dr. Cook here wrote. Just kind of for fun, if you consider E&M fun, which that's been fun for me at least. Some Scala today and had a good time. Ooh, nice. Okay, and Dr. Cook confirms the answer here is C. 2 particles minus Q less than 0. Yeah, I do remember you telling that story. Yeah, this book that I've been going through, it's got a lot of multivariable calculus, and it's I'm getting my ass handed to me by the problems and by just like how it explains the concepts, but there's some really fun math in there. It keeps me like motivated. Like, yeah, there's like Laplacians, divergence, curl, all that good stuff. Just means a Coulomb. So problem time, we have 2 particles minus Q less than 0 are a fixed distance L apart. Each experiences a Coulomb force of magnitude F. Particle plus Q greater than 0 is then fixed halfway between the first 2 particles. So each negatively charged particle can now experience a net Coulomb force of magnitude F over 2. The value of Q must be... Math and physics came together, had a beautiful baby. Yeah. I mean, beauty's in the eye of the beholder, but I definitely agree. Suppose the other physics textbooks that throw math out the window. Yeah, I really like how this is being taught, because it's not just like memorizing formulas. You get to like derive them and know why they work. Hey, Kathy Prime, you know the math category on Twitch? Yeah, I think the story with it is that there was a game called Math at some point that me and a handful of other people just hijacked to talk about actual math. Yeah, I'm not the only math streamer who's out there, so I guess for anyone who might be new, there's a whole list of math streamers out there. Other people here do math help in some form. Yeah, it's really funny this niche exists, but there's some really cool people. And Dr. Cook's been hanging around too. He's on that list, but he also streams. That's my assumption, Waffle. I don't know what the game was. Actually, that'd be cool to see if we could figure it out. But like, the category comes with a puzzle tag. So that's what makes me think like, you know. My life is a lie. Math was just a game all along. I how do we think about this? This feels like a superposition thing again. It's a joke. I hired to be a backend developer for a video game. Turns out I just work on the characters' butts. That one I would have understood as a joke. Oh god, you got a snort out of me. That feels like something, oh, the dude who made Nier Automata, he was asked why he made the main character like a hot girl, and he was like, I like looking at hot girls. I feel like he would hire a back-end developer to work on like characters' butts. Jiggle physics go hard, true. We need more of them. Each negatively charged particle now experiences a net Coulomb force of magnitude F/2. So the first two charges push on each other with the force of F. And the positive charge that we bring in brings the net force, it cuts it in half. B? Because the F total on one charge should equal the force from the negative charge plus the force from the positive charge. And that means the positive charge should be half of the negative charge. And Q/2 would get us there. Because we're not changing. Oh, wait. Distance. True, yeah, okay. So far out of my field of knowledge, give me Rust. I've been doing some Python programming, but I'm so terrible at programming. I technically minored in computer science when I got my bachelor's in applied math, but I've forgotten so much of it. Oh, you know, on Saturday we're having a little coding competition with another math streamer, Zach, or Eats a 2i Pie. Which will be fun. So wait, so the distance is cut in half, which means there's a factor of 4 up top, and we need to go from a factor of 4 on top to a factor of 2 on the bottom. So it's Q/8. Yeah, Q/8. Femlox has a quibble. Quibbles Kind of a funny word. I have a quibble with that. D is correct. Claim that 3q over 8 could also be a solution. Oh. Why? If the force flipped around? I don't see that. Scrimp is saying the force on minus q by plus q is k minus q plus q over L over 2 squared. Subtract that from F and solve for q plus. I think it's what I like mentally did without doing it that formally. I should have said something with magnitude F over 2 in the same direction. So the negative charges are repelling each other. Wait. Oh, you want to say that? I mean, you could just change the wording to could be. Okay, so yeah, what will be happening there is that your positive charge will get so big that it goes from an inward force to an outward force. Okay. Or wait, no. It was already outwards. It goes from outwards to inwards. Net. Okay. Valid quibble. Exploring parallel plate capacitors, all which have plates of the same area A. Well done. Have a Rubik's Cube? Oh, hey. Okay, yeah. Let's, I didn't even see that. Where's my timer? Right there. Okay. I love picking nits as, yeah, I can attest to your love of picking nits. So just scrambling it right now, not solving it quite yet. Okay, scrambled. We get some inspection time. Okay. Oh, this is always my worst part. It's hard to find the pieces that I need. An N-perm? Like the worst one. Yeah. Could have done better, but not bad. Thanks for the redeem. Like half your best time. I meant the I don't like having to do when you have the top layer like this, I don't like the permutation you have to do to fix it. It's kind of annoying. It's called an N-perm. I'm probably gonna mess it up. My favorite one, I think it's called the Z-perm. You use the middle a bunch. Yeah, and it solves this case here. Wait. I think I'll solve the top layer. Oh no. There's a basic method that. So I do a more advanced method. We get to memorize a bunch more algorithms, but there's like a more basic one where you only need like 2 algorithms, I think. 3. It's with a fish. I don't remember a fish one. I don't know all the methods though. Anyway, problem 8. Which of the following parallel plate capacitors, all which have plates of the same area A, would store the most energy for a given applied potential difference V? Store the most energy for a given potential difference V. Vacuum, glass, smaller distance with air, smaller distance with glass. I don't think so. Are these called dielectrics? I don't think we've gotten to that in the Purcell and Moore thing. Let's see if we can think about it. Doesn't know about the fish, minus 10 points. Oh, is it? Oh, is this the fish? I think I see it. I just like never heard it called that. Yeah, okay. Well, I'm gonna hazard a guess that plates that are closer together store more energy. And then between vacuum, air, and glass. I assume this is what medium would be the easiest thing for an electron to get through without any extra effort. Which would lead me to think of vacuum. Where that would be C. I think. Hey, Stelly, how's it going? He's been stuck on a Rubik's Cube, you don't know how to flush him down the toilet? I think that room was called like the right soon. It's you get it to like the head of the fish is in the like the lower left, and that you have like that one facing you. And then you go right, up, right, prime, up, right, up, right, prime? No, I messed it up. It's all muscle memory. That room is called right soon, though. It stopped working? Oh. Going E, but no good reason. U is 1/2 CV squared. You want to maximize the capacitance. C equals A epsilon naught over D. Right. Vacuum is the worst case. Okay, so, I mean, I'm not, I correctly understood that we wanted the smaller distance. I just didn't know how to distinguish between vacuum air and glass being a better dielectric, so we haven't gotten to that part yet, which I'm not gonna cry about. Oh, do you solve Rubik's Cubes too, Stelly? I guess you must if you're saying that. That's awesome. Yeah, that looks about right. I can't do them slowly. Like, if I think about the algorithm, then I mess it up usually. Yeah. Cherry Cuban did it. Two capacitors are connected via an initially open switch S as shown below. When S is closed and the circuit reaches equilibrium, which of the following is true, for the charges on the capacitors and potential differences across them. Yeah, Fembox, and it's like clockwise if you're looking at the face. So if I'm holding the cube with the blue towards me, right would be the right side clockwise. And R prime is counterclockwise. Can I solve, okay, Curious Aspirant on YouTube says, can I solve CFA questions? CFA to me means Chick-fil-A, which I can certainly answer a question about Chick-fil-A. Chick-fil-A is awesome, but I assume you don't mean Chick-fil-A though. It depends on the question, I guess. Or like, do you have an example or something? Chick-fil-A. You know, if you want to like which sauce at Chick-fil-A is the best. Actually, I've only ever gotten the Chick-fil-A sauce because it's just so good. Oh, dude, that'd be cool. Just go to Chick-fil-A and get every single sauce. The thing is, I have to see if I can remember. There was one Chick-fil-A by me that just had all their sauces out and you just grab them. And that was my favorite Chick-fil-A because if you, at every other Chick-fil-A, you have to ask for the sauce and they have it behind the counter. And they're always so stingy with it. When the sauce is the best part about going there. Yeah, like after you do that, you should have like the very top face solved, and then you have to permute around the corners, I think. Or maybe even the edges too. How much is grilled chicken sandwich if you can only eat 36.3508 grams of it? Huh? You still have to pay the same amount. Shim Krar over on YouTube. Can you teach me exactly differentials, please? I don't know what you mean with exactly differentials. Do you have an example of a problem? Two capacitors are connected via initially open switch S as shown below. When S is closed and the circuit reaches equilibrium, which of the following is true about the charge and capacity potential differences across them. So C2 has twice the capacitance of C1. What if I wash the dishes for 33.806 hours? That's a good question. Okay, well, capacitance is charge divided by potential, volts. What is an exact differential? Oh, an exact differential equation? Does an equate, like, are you talking about like an equation, something like this? Uh, for me in California, Curious Aspirant, it's 4:38 in the evening. So I guess we're nearly 12 hours apart. Okay, I'm not hearing back from right. Shem, I'm happy to talk about exact differential equations. I don't know if that's what you mean exactly. Let me know if this is what you're talking about, but I'll drop the link to this in chat in case maybe you have to leave and you check the VOD later. This site I really like for everything. Oh, okay. You learned about exact differentials and thermodynamics. I haven't studied thermodynamics. But this site does like tell you how to solve a differential equation that is exact. And if you want, I can like work through one of these. But I don't know if that's exactly the thing that you like need. Hey, RCR, according total differential as opposed to partial. Right, yeah, I'm wondering if that's like another interpretation that it could be. I wonder if I can just like exact differential equation thermodynamics. The perfect exact differential. I know there's a perfect exact differential. Is this an exact differential equation? It looked kind of like it could be, but it also looks more like chain rule, I guess. Hmm. Hey, Husky. Wow, this is a long answer. Um, yeah, Shim, I feel like this is something that I think it's maybe an application of this like, idea of an exact differential equation. I have no idea. I feel like in the context of actually, I don't even know. I think I'm out of my depth here in thermodynamics. I don't really know. Oh, this might help. Means you know the fish Rubik's Cube algorithm? Yeah. 2 plus 2 equals fish. Please protect. Yeah, so Shim, actually Husky, a dedicated optics book for Olympiad. I don't know how to help you there. I have never tried to study for the Olympiad. I don't really know where to start for that. And then Shim, I can link you to this too, just in case, but oh, okay, let me see what's scripted. Because I don't think I can really... I can solve an exact differential equation like you would encounter in normal differential equations class, but I don't think that's really what you're asking for here, right? I think it's really... I don't think that's what you maybe need help with. Oh, maybe it is, I don't know. Don't like fish? Oh. Gonna say really quickly, I'm not coming back, so I just noticed very tired. All right, please get your sleep. I thought you already went to sleep, to be honest. The fish man isn't sleeping. So yeah, Shim, this is what Scrim put in chat here. I feel like I know I bet you I know the math behind this. It's just applying it in this context that I don't know. Let me snip it. Yeah. Can you not read cursive, Stelly? Actually, your handwriting is really nice. Like, when I write in cursive, it takes me forever. Hmm. Oh, I get it. It's for the week, so you do it throughout the week. Huh. These guys are bullies. If Waffle is bullying you, then you probably deserve it. All right. Can you tell me what exact differentials are? I don't have a background in multivariable calc. So an exact differential. So in the context that I learned it, it's only in... Yeah, I learned about a single variable context where if you have a differential equation, an ordinary one that can be written like this, you say that an equation like this is exact if it if the partial of m with respect to y is equal to the partial of n with respect to x. And if that condition is true, then this differential equation up here is exact. And there's kind of a procedural way that we can solve it. And I think this idea is being used over here, but there's some partials involved that make it a bit weirder that I don't know how to handle necessarily. Too poetic for this world. Hmm. Oh, you went over to YouTube too? Hi, Stelly on YouTube. Doing some mathematical gymnastics, you can find differential equations for entropy, volume, and temperature. Yeah, Shin, that's kind of what I'm struggling with right now. Like, Probably. I mean, you weren't being bullied. Community YouTube channel set up for educational content. I mean, that'd be cool, but I don't know exactly how that would look. How about this, Shim? Is there a specific thing in thermodynamics that uses this that you want to know more about? Like, can you say the name of an equation or something? Or an example of a problem that uses this? I'm joking, I think, half the time. Okay, or if you just go with that, Shim, I'll leave it there. I'm sorry that I can't help you more specifically, but I'm just kind of afraid to like show you something that isn't actually relevant to you. If you want to like give me something more specific to look into, I'll try, but it's a little bit hard to answer just like broadly like exact differential equations and thermodynamics. It seems like there's a couple of different things that it could be. Am I gonna play the new Wukong thing game, Dawn? I didn't know Wukong was getting a game. Or, oh wait, maybe I've seen ads for it. Is it the League of Legends Wukong, or like, either way, I'm probably not, but. Black Myth Wukong. Super duper monkey game. But yeah, so I know Wukong is a League of Legends character, but I think like I don't know if it's by name, but like Wukong is also like a from like Chinese mythology or something, like some kind of like tale or like something like that. I don't know if they're basing it off the game or either way. I'm probably not. He's monkey. Well, yeah. There's already a cool video game monkey, and his name is Donkey Kong. And he has barrels instead of a stick. When S is close, circle reaches equilibrium. He makes monkey noises and beats people. Circle reaches equilibrium, which is holding is true about the charges on the capacitors and the potential differences across them. So the charge on these is going to be equal if it's in equilibrium. Well, is it necessarily going to be equal? I feel like it should be. No. If it's equilibrium, the potential should be constant throughout. I feel like. Which would imply that capacitance is charge over volts. And we're holding volts the same. So C2 only requires half the charge of C1 to reach the same potential. So E question mark? Q1 has twice the charge of Q2. Well, the other answer would be B. Mitchell Hooper? Never heard of him. If the capacitance of C2 is twice as much, the strongest man on Earth? I'm going to see if I Google Mitchell Hooper. Oh, okay. I never heard of this guy. Strongest man on Earth a few days ago. Huh. I wouldn't fight him. That's my thought on him. 6'3", 320 pounds. Nicknamed the Moose. He was born in 95? He's 2 years older than me. He looks like he's 10 years older. Like, imagine that he's bald. You don't think you can beat him? No, I don't think I can beat him. Welcome back, Husky. Oh, if you didn't hear the... Like, I don't have a recommendation for you, Husky. A dedicated Octobooks for Olympiad, I want to know where to start with that. Actually, wait, he's 28 years old right now. Oh, yeah. Thank you, Waffle. After Bjornsson? Oh, Icelandic. Oh, was he in Game of Thrones? He looks familiar. He was? Okay. He's also strongman. Okay. No more Game of Thrones. Your history teacher talks about it enough. I think I'm sticking with E here. E makes I don't like doubting Fenbox, but like I feel like C2 is twice as good as C1. It only needs half the charge. It's more efficient with charge for the same volts. It's B. Okay, fine. Why is it half? Wait, ask. Yeah, I jump around topics a lot. E&M Mitchell Hooper, it's basically the same thing. Q equals C times V. Oh yeah, I mean, I was doing the rearranged version, which is C equals, I mean, okay. But that's maybe more helpful. Q equals CV. Q over C ratio is constant. Dang it, you're right. Okay. I should have just done that. I thought it means it'd be more efficient. Like, you don't need... With less charge, you have more volts. Efficient at soaking up... Oh, efficient in the wrong sense of the word, I guess. Huh. I don't have a good intuition for what capacitance means, I guess. Husky, you want to do the integral of ln of sine of x? That's probably something terrible. Shit, that's not... Let me just do the indefinite. Unless integration by parts miraculously works here. No. Yeah, that's... It's probably a competition integral or something that I can't do, Husky. If that's even possible. Wait, 10... No, I'm not skipping one. Okay. Parallel plate capacitors charged by a battery and subsequently disconnected from the battery. The distance between the plates is then increased. Which of the following is true? Field strength decreases, the field strength increases. The potential difference between the plates increases, the potential difference between plates increases. Extra field strength and the lower potential difference will change. Oh, is it a book for Olympiad problems? I can't do Olympiad math, Husky. So you're sidetracked on from time to time. I'm thinking about how my gut is saying E. Because you can't... If the field changes, the potential must also change. So I'm just thinking, like, logically, it can't be B, but not also C or D. I think. But I'm trying to rationalize that in a more physics way. Do I have a good gut? I like to think so. Oh, because of the typo. Okay. I have the greatest gut. Yeah, I'm sorry, Husky. Like, even if it's not in like this. This is just some crazy difficult integral that you don't have to do as a normal like calculus class, at least here in America. And I never learned how to do integrals this hard, and I don't think there's really a use in being able to do them. I'm sure it'll be somewhere on Google if you look it up, but I don't know how. Wait, okay, maybe. Increasing the distance lowers the capacitance. And if V equals Q over C, a lower capacitance is a higher potential difference? But the field is the same? That's annoying. Why doesn't changing the potential necessitate a change in the field? Because we're changing the distance, I guess. That's not your answer either? Oh my god. Zero still, he says? Oh no. V equals E times distance. That's... No, yeah, you're right. But the thing that kind of confounds this is that we often approximate the field due to a capacitor as an infinite plane that doesn't vary with distance. I think I'm kind of going back towards E. I don't know. Wait. Wait. This over S factor might cancel with that V equals E times D thing. So maybe it is possible to have the potential increase in the field stay the same. Do you... Oh, I have terrible intuition for circuits, RCR. But that probably is a good way to do it. This is annoying. I think the book did an exercise like this, or like an example problem like this. You're saying A. I'm just saying E. If I'm assuming taking this under time constraint, I'm sending E. I feel like neither of us are right. I could see maybe being able to change the potential, but not the field. I don't see changing the field without changing the potential. Hey, Brian. Yeah, I'm definitely ready. D? I should have changed my answer. And so does the field stay the same? That's what this question implies. A mouse. He'll eat your cheese if you bully me anymore. Do you understand that? You call him the mouse police? That's a mouse? I can kind of see it. The charge can't change, so neither can their electric field. Huh. Well, but the electric field at any point between the plates should be weaker, though, shouldn't it be? Unless we're saying that these approximate infinite planes. That's only true for very close to the capacitor, though. If you extend the same slope over a longer horizontal distance. I don't get that gravitational analogy. Can get infinitely far. Huh. Where did, like, I think I remember them talking about, like, what happens to a parallel plate capacitor as you pull them very far apart. What's your idea for it, Husky? Sporadic math messages in between the mice. Okay, so we're increasing the area of the plates as we pull them apart. Then I'd feel comfortable saying the electric field is constant. I didn't get that from the wording of the question, though. Yes, that's kind of what I was thinking too, but that seemed like it should influence the field at the same time. If battery is connected during, the potential is held constant during the process. The battery is disconnected, the charge is held constant. I guess, how is electric field strength? It's still the same amount of charge putting out the same field. Is that the logic? I guess so. Like, each of the plates are putting out the same field. They're just the fields are centered at different points now. Ugh, I guess so. I was thinking about like in the area between the two plates, or sorry, in the region between the two plates, the strength of the field is weaker at, you know, basically at every point between the plates as you pull them apart. That's the wrong way of imagining this. It's still the same total charge. But I think that my struggle with that, like, infinitely large approximation is that we're pulling them apart. And I feel like that's gonna make that assumption not apply as much. I guess if we're allowed to just say that, then I'm on board. I was assuming we were holding the area of the plates constant, and that if we're pulling them apart, that's not necessarily a negligible difference, or it could be a significant difference that we're pulling them apart. So I don't know. Well, yeah, but what if the wording of the question doesn't exclude pulling it from 1 micron to 2 miles? Like, if the distance is increased slightly, I'd completely agree with you. Maybe I'm being nitpicky now too, though. Violate the assumption of parallel plate capacitor. But you can be a capacitor with something relative to infinity, can't you? E&M is terrifying. Ugh. The math is really fun, but the areas where physics and math differs are kind of scary. To me, at least. Yeah, Husky, I agree, but I'm just saying that, like, or the cook seems to be saying that if you have a parallel plate capacitor, that implies that they're close enough. They're close enough relative to their areas to be a capacitor. But I'm thinking that why can't you have two parallel plates that are, you know, infinitely far apart and still call it a capacitor? All right, I guess that's fair enough, Cook. And I'll chalk that up to my own lack of experience. Oh, jeez. Okay, I can just barely fit in the entire problem there like that. Community's afraid of the unknown, and I'm no exception. Inception? The second one, yeah. Waffle. All right, see you, Husky. And hello to Nani. 4-point charges of charge Q are fixed in place in the XY plane at points. Okay, we have a square of side length A of 4-point charges. What's your field? E of A over 2, comma, A over 4, magnitude and direction at A over 2, comma. Wait. You're kind of scaring me with that, Stelly, but okay. What? I'm looking E of A over 2 comma A over 4 at A over 2 comma A over 4? This seems redundant, but I feel like I'm misinterpreting something. To have the point listed twice. Yeah, Joseph, this is a midterm that Dr. Cook wrote. I want to put this problem into Paint. It's trying to be... Okay. Thank you. I just want to make sure I wasn't, like, missing something. You know, silly, because you're just a little bit extra. That's why. Oh, that looks terrible. Oh, that looks... Well, that looks even worse when it's not even there. Okay. No. That's not what I want, Paint. Okay. Origin. Zero A. Hey, the alert worked. Thank you for the 1-bit waffle. Now it goes for slightly too long, but... Oh well. Now this problem you have confidence on. Okay. So A over 2 comma A over 4 is somewhere about there. Let's actually make that a different colored dot. Could have picked better numbers in hindsight. Okay. I guess let's number these charges 1, 2, 3, 4. So E sub x in E sub y is probably how we want to do this. So in the x direction, 1 and 4 agree with each other. 2 and 3 agree with each other. And with respect to x, they're the same distance away. So we could say this, is 2qk over a over 2 squared minus, oh, not 3 and 4, 2 and 3. That's a 3, I promise. Oh. I guess that makes sense. Does it make sense? Yes, it does make sense. The y's will be different. It should have a net force going upward. Ah! The bots, they figured out a way past the automod. The automod was doing a pretty good job of catching those messages, but not that one. The best viewers already here. In the y direction, 1 and 2 agree. I mean, let's do 3 and 4 first. Stella, you should not. You should go out of that web page and do a virus scam. You should not have clicked on that link. If you're being serious. VM, all right. As long as you know what you're doing. All right, and then we can clean this up. Not equals. PC's infected. Do you only use Python? That's what I have only been using recently, critical. I have written code in Java, C++, MATLAB. A decent bit, just not recently at all. Maybe a smattering of other languages, but... Oh god, I technically did some PHP and HTML. Don't ask me to do those, though. Those are terrible. Um... 32kq over a squared 1 minus 1/9. How hard is it? I'm going to start next week. Python is a pretty beginner-friendly language. It seems they don't expect as much of you as other languages do. Oh, for Java? Java isn't so bad either. It's what I learned on. Java data structures. Some distances in the denominator. Am I? Oh. I need my cosines and sines. Okay. Alright, Stella, calm down. I don't know what that address is. I'd rather not have it. I don't want to know. I'm just going to put cosine theta and cosine theta to be lazy because they should cancel. For this one, 3, 4. Yeah, this has felt like a pretty nice, like, difficulty for me. Nope. Dude, let me move you. Fine. I use the arrow keys like a pleb. All right, so we want sine of this triangle. Ah, curse you, paint. Well, if Cook students were anything like my classmates, they sure as hell didn't appreciate it. There's nothing my classmates wouldn't complain about, dude. It was kind of annoying. So sine theta is opposite over hypotenuse. So opposite is a over 4. Hypotenuse is a squared over 16 plus a squared over 4. Ugh, and we need the same... No, not quite the same. A similar factor. Ah! Over here. Ignore me as I scream. Use the Pythagorean theorem. But I still need a... Oh my god. Wait, I messed up the original distances too. I still need the sine theta and cosine theta, but these are also just wrong. I'm just going to call that r squared for the e sub x's, because they should just cancel. Do we need the distance squared? Why not sine theta and cosine theta? I'm getting the x and y components. Hope your exam this year is like y equals mx plus b. So good. Oh, wait. I'm making this harder on myself than I have to. If I know the x components are 0... No, I think I need the sine. Why don't I need the sine? We could get the total magnitude. And maybe in Discord crying for help with trig. Trig I can definitely do. If it's those weird integer digit problems, I'm going to struggle and need help from chat, but... You know the delta x and delta y because the points are given. Right. But if we need the direction of this vector, don't we need the x component and the y component? All right, see you, Stilly. The direction is trivial and the magnitude is separate. Well, what I don't understand, and my vectors for this are really weak, or my vector knowledge for this is really weak, is that it's not just the total magnitude of everything added together, like without regard for direction. The x, like a certain, we can't just add up the magnitudes blindly of each of these 4 points because the x components cancel. It's going to be some fraction of all their magnitudes added up. So at least before I look at what you put, Cook, like what I would do here is like this for the charges from 3 and 4, and then A similar thing for charges 1 and 2 and just try to simplify it. But I like there definitely like the net force should be just something directly upward. Maybe there's a more convenient way to do that I should just look at your notes for. I'm bringing that up, so if you don't want to spoil, then don't look. Oh God. Oh. I mean, I think that I would have gotten the same thing. With how I was doing it. You got all the unit vectors. Yeah. That's probably a little bit easier on the eyes and like easier to track. And also, you wouldn't have a ridiculous thing to simplify like this. But I think what I've done, like, if I kept going this approach, I feel like I should get the right answer too. If it'll be a lot more tedious. Did this type of problem like 3 times in class, you tell them it's very algorithmic procedure, getting the vectors and the unit vectors. Okay. It's probably better than, I'll admit, that's probably a better way than doing it like this. This is the way that we have been doing it in the reading group, but like, I'm so bad with, it's been a long time since I had to like use vectors like this. The solution, yeah. Oh, you mean, okay, you're saying that I put it on stream. Yeah. Okay. Let's see what this one's about. 2 concentric spherical conductors carry a charge -3q and 5q. Yeah, I think I probably, it might be worth it for me to go back through and do that calculation for myself. I think I know how to. It's just a lot of numbers to crunch. Oh, okay. The charge on each of the following surfaces, R equals A, or R equals B, R equals C, and R equals D. Okay. We just need a little gap in the top there, and we have that one problem. Hey, Ridham Patel. For r equals a, I'm going to claim minus q. And so for b, that leaves over a minus 2q. Having a computer networking exam today. Ooh, good luck with that. I know very little about networking. It's I know like a little bit, like the three-way handshake, TCP/IP. You know, I can throw out some buzzwords. There's some interesting stuff in there. What do we do about C? I mean, it's a I mean, I assume C still wants to cancel the 2q. Do we get a... Oh, wait, that's positive 5q. Okay, never mind. I thought it was negative 5q for some reason. If I could have this game back, I would have chosen a simpler point. Numbers are gross than I would have liked. Oh, okay. Finbox agrees. Okay. Calculate the potential difference delta V equals V outer minus V inner between the conductors. Oh, there should be an easier way to or actually, there should be a way to. There is a way to do this, but I'm trying to remember it. Do we need the capacitance of a sphere? Actually, we don't say no. I was in the Purcell book. I think they do an example of a capacitor like this. It might be a... Yeah, we should know how to. You're right. Fourth grade, so seeing a variable on a knowledge check, reading these. I don't know about seeing a variable on a knowledge check. Yeah, I'm not sure what that means either. Or I'm not sure what that means. Spirit. Oh, okay. Oh, okay. Is the So I'm thinking I assume we need to set up an integral here to go from the outer shell to the inner shell. I'm trying to figure out what the field would be, though. Because I'm applying Gauss's law in my head in between the two shells, and we just have a net minus 2q charge, but I feel like, don't we need to involve the positive 2q on the inner surface of the outside? Do you need a minus sign? You probably do. I feel like you do. I don't know. I'm thinking something. Oops, not D. C to B of E dot ds, but we're just traveling like. I feel like the minus sign, you don't want it. I don't remember how the formula goes. But I guess my question is, what is E? Is it just minus 2q? Yeah. Basically, my question is if this should be a 2kq or a 4kq. And I feel like the minus sign out front is bad. Maybe it's not. I don't know. I'll fix the minus sign at the end if it doesn't make sense. I think it's supposed to be negative work because we have a negative charge on the outer part of the inner shell. And my gut says to do 2kq, so I'm going to go with that, I guess. C is greater than B. This value in here is positive. So we do get negative total work, which I think is what we want, or sorry, potential. I feel like it's very possible I've done something slightly wrong here. Wait, R, no R. Get rid of the R. I don't know how to erase in this stupid program. Because I can't select just that piece. Oh my god. Why? I'm not redoing all this, but like that over R isn't supposed to be there. Oh, Control Z. Oh shoot, an astronomy show, hey. It's good to see you. How are you doing? Don't mind me as I rage at technology. It's what I usually do. Finluck says, let's think about what happens when B goes to 0 or C goes to infinity. If B goes to 0, you basically have a point charge with net charge minus 2q. With a shell outside of it still. And this will be consistent. That means the potential would blow up here, which would be consistent with a point charge? Question mark? And if you let C go to infinity, is the other thing you want to check? You would have just minus 2kq over b, which is just the formula for potential relative to infinity. So that seems like it makes sense. That seems consistent. I know, I think I'm ready to see if I'm right or wrong here. Is that what you put in the chat, Cook? Let me see. Okay, yeah, it looks like it. All right, spoilers. I'm bringing up the answer. All right, minus q minus 2q, minus q minus 2q, plus 2q plus 3q, good. Our A is good. Oh. That's a much simpler, well, I did it the hard way with deriving this, but you know, it's what you do. The outer shell should be at a higher potential. Really? Oh, yeah. Well, wait. C minus B. Multiply this thing. Ugh. I can't do mental math. This would turn into C minus B over BC, right? Because that multiplied by C over C, that's multiplied by B over B. Oh, so I am off by a sign, aren't I? Okay. So I think that minus sign that, okay, wait, did I just misremember the formula? Where it should be in this one. No, there's a minus sign in front. Then why was my thing in the field is negative? Why am I off that minus sign? Draw my directed path of integration explicitly on top of the electric field. Then look at E dot ds. Well, the field is going inward. Right? Just fact checking that. And I'm integrating in the same direction, aren't I? I'm going from C to B. Outer minus inner. Oh. C goes with outer, B goes with inner. Okay. All right, fine, that's fair. Oh, a dipole question. I don't remember dipoles that well. Let's see if we can figure this out. Electric dipole P equals P cosine phi sine phi. I did more heavy lifting than was necessary. I could have done much smaller amount of lifting. Oh, so Sophie, morning to you too. How's it going? Some of the electric field lines, also in the outer, should be at a higher potential. Girlfriend is resting. We're going out soon. Okay, nice, nice. You know, I appreciate you saying hi. It's been a minute. Yeah, that makes sense, Cook. Dipole P equals P cosine phi sine phi is placed on a uniform electric field 0 e sub y, where P is greater than 0, e sub y is greater than 0 are constants with dimensions of dipole moment in electric field respectively. Calculate the electric. Huh. I'm trying to work out how this dipole is oriented. That must be implied by how these vectors are set up, but is the dipole vertical or horizontal? And I forget what the dipole moment... Okay, you know what? I'm about to check the book to look up what the dipole moment is. Before I do, let me at least look at what the question is. Potential energy U of phi of the dipole configuration. Sketch a plot of U of phi. Oh, it depends on phi. I guess that makes sense. Right angle phi is the dipole in stable equilibrium. Oh god. I have no clue here. I'm gonna look in the book for stuff on dipoles. So the dipole moment is the charge, like the positive charge, that value times the distance between them. Oh. Spoiler alert. Oh, wait, do we have to... U of phi. We're not expected to derive the potential with this like approximation stuff and get to this equation and then multiply in the other charge of the dipole. And the fact that it exists in a uniform electric field is really messing with me too. Oh, we have to do a similar calculation as this, but in the presence of a constant electric field, maybe? The energy of it. Oh, really? I don't think the text covers that then. Unless it does. I mean, is it this thing? Oh, yeah, that's probably the idea for part B. So that the positive charge points is like further up. It's a relatively simple formula for the energy of a dipole oriented in a uniform field. I kind of want to Google it because I really don't know. I don't think the book covered it, at least. Unless we can just use this phi and like multiply in the minus q charge. Actually, no, but that's not in a field. Yeah, I don't think we covered this. Energy of a dipole in an electric field. Minus p dot e. Okay, well, that is pretty simple. Wait, is that actually the... Yeah, okay. So that means u of phi is equal to minus p dot e, which equals minus p e sub y sine phi. Terrible phi. Slightly better phi. Very slightly. And sketch a plot u of phi. For phi belongs to 0 to 2 pi. Oh, this is a weird thing to get for potential energy. It's a negative sign. I should have put y equals in front, but... That's super weird that the potential fluctuates. Oh, depending on the orientation. Oh, wait. I'm visualizing this wrong. So wait, if it's pi over 2, that's pointing straight up, and that's 0 potential. Because that's the way it wants to be. My scaling isn't right, is it? Dude, I don't... Oh my god. Wait, no, this is pi. No, wait. Oh. Oh, it depends how phi is defined. I don't know how it's... The positive charge should be on top because the electric field is pointing up. And I can see how if you were to rotate it, why would you be doing negative work, though? you would be doing negative work if you go from the exact wrong orientation to the exact right orientation, I guess. Yeah, I don't know. I'm going with this, but for what angle phi is the dipole in stable equilibrium? I think I just described it verbally. Stable equilibrium is the positive charge. Ugh. If the field is like this, the dipole should be like that. That's stable. Unstable is you flip the dipole 180. I bring up the answer. Oops. Because I just don't have the same like or we didn't like even, or I don't necessarily know even how like phi is defined for stuff like this, so I don't really mind just looking at the answer here. Unstable equilibriums at pi over 2 and 3 pi over 2. Okay, that must be, okay, so it is, that means that it's the angle the positive charge has with, and, okay, yeah. Okay, I think I got the concept. If I could have labeled my graph a bit better, but. Put the table below, find the charge on. And I guess the book does define the vector associated with the dipole. Like, is it pointing from the negative to the positive? I remember it noting that in chemistry they do the opposite. I think that's how they define it. I don't know. There's a footnote, I think, where they said that. Should be wherever the footnote is. No, I don't see a footnote. Okay, who cares? Not me. It points from negative to positive. Okay. Oh gosh, what do we have here? Complete the table below, finding the charge on and voltage across each of the 5 capacitors in the circuit diagram. Should be given in terms of C and delta V. The charge on and the voltage across. Okay, so going back to what Cook said earlier, there's like the 2 types of problems. One is where it's connected to a battery, others where it's disconnected. This one is connected to a battery, which means the potential is constant, but the charge can change? Question mark? So I'm thinking that maybe it's dangerous, but could we just put for voltage across delta V all the way down this column? I need to consider the actual, what's going on with the circuit though. I guess do they have a share of the voltage depending if they're in series and parallel? Like, like this loop should have the same total, delta V. Okay, yes. Okay. So we do need to share, okay. So C4 and C5 have a share of delta V. Okay. Oh, really? Okay. Yeah, wait. Differential between some, not all circuit points, delta V. So I'm gonna, I think for this, we can say for the entire loop on the right here, that's delta V potential, because you can get from the plus to the minus across this. And the same can be said of the entire left loop. So C4 and C5 have some share of that total delta V. And we could do something about it, I'm sure. If they're in parallel, or sorry, if they're in series, capacitors, you have to do that 1 over reciprocal thing. I just remember the capacitors being weird and backwards of what I would think. Okay, so C4 is 2C, C5 is 3C. So if we were to combine them into one, it would be 1 over 2C plus 1 over 3C, question mark, which comes out to be, drum roll, 6C over 5. Probably. Do I even need this? Why is this helpful? There may be shortcuts. The leftmost capacitor is easy. Not if you're me and you suck with circuits. Capacitors in series hold the same charge? Do they? Oh, because the constant potential from this plate to this plate. Maybe? No, but if the potential is the same, the charge would have to... No. Well, yeah, no, but then... Okay, wait. If there was a difference in charge, they would, like, become equal, because there'd be a difference going from one plate to the other. They're equal potentials. Okay. And that seems like something. Oh, the level of capacitor is easy because you could consider this 3 separate loops. The voltage across it should just be delta V. Which means, and the charge on it is C times that? Just considering the loop from here, only considering C1 over there. We have another loop to consider getting through C2. I mean, that seems weird though. No, I guess, no, it might be, okay. Oh, it's like, wouldn't it be the same exact, wouldn't C2 and C3 be the exact same problem as C4 and C5, but they do have different values for their capacitances. We could say Q equals C4 V4 equals C5 V5. Any 2 points connected by just wire must be at the same potential. Right, okay. Draw with Amaresh over YouTube says, find dy by dx equals log of x plus y. Oh, that's a nonlinear. And I don't think that's separable. Let me put that into Wolfram Alpha, because that seems like a difficult differential equation. I don't think I can do that, draw with Amaresh. That's a pretty difficult differential equation, it seems like. These don't separate, though. If it was x times y, you could. But when it's x plus y, you're just kind of stuck. Oh no, now I can't write in this box. Oh my god. Why do you do this? Like, why do you hate me, PDF thing? Okay. I already have a snipping tool open. Okay. And we know that C4 is 2C. We know that C5 is 3C. That seems... This doesn't seem right. It's from C1 equals 2 plus 4. I'm not sure what that means, X factor. You think, oh wait, you're saying this is good, Femvox. We have Kirchhoff's voltage law for that loop. So V4 and V5 should equal delta V. What do we do with these coefficients, though? Two equations and two unknowns in V4. Where's our other equation? Oh, equal to Q? I'm confused what the second equation is then. Right. Oh, okay. That's our second equation. I was trying to manipulate this to get a V4 plus V5 in there, but yeah, we can just treat that as a separate equation and like do a substitution. So we want to solve this for V4. 5V4 equals 3 delta V. V4 equals 3/5 delta V. Okay. Oh, that makes, well, doesn't it? It makes sense that we have fractions of 5 between C4 and C5. I'm curious about why they're kind of... The one with lower capacitance has a higher share of the voltage. That's something I want to think about. But, I guess we can go back to, like, these equations to get Q. Multiply that by 2C. So 6 over 5 C delta V. 6 over 5, oh, C delta V. Huh. And I guess the same exact calculation can be done for C2 and C3. I mean, we can just use the pattern. Why even bother? That's what I always say. There's no reason why it should follow a different pattern than what we found down below. C. Okay. So why does the one with lower capacitance have higher potential? Because you have to do coulombs per volt. C is coulombs per volt. If you double your capacitance, you're doubling the charge, which we're not, or we're having the volts. I didn't get it, I'm not Albert Einstein. It needs to have the same charge when in series. It needs a large potential across it to have the same charge. Ah, okay, that's a better way of thinking about it. Okay. Cool. Einstein Nebula? Oh my god. That's such a good, like, Photoshop. Looks like the answer... Wait, did I mess up using... Okay, no, I got it right. Nice. Then we already did this one separately. You found a book by Einstein? Oh, that's cool. How many more do we have? A long answer? Just a long answer. Wait, are there two part Ds? No, never mind. There's... That's true. I mean, maybe that you know, the universe is infinite. Maybe there's a nebula out there somewhere. Actually, well, not infinite. That's the wrong word. Expanding. I know, you're the one who knows space. Flat disk radius A lies in the xz plane, carries uniform surface charge density sigma. Oh, I was, you know, in my super brain, I'm like, you know, maybe there is a nebula that actually is shaped like Einstein out there, but you're saying about the name, that's probably more reasonable. I mean, yeah, I guess, how do they name nebulas? They usually get, it's usually like just like letters and numbers, right? Shape is possible? Okay. And hey to, oh god, I'm gonna butcher that. Abhinanditha on YouTube? I'm sorry I'm pronouncing your name wrong, but welcome in. Calculate the infinitesimal electric potential dV produced at the point 0, y 0 on the positive y-axis by the annular region. Gray in the above diagram, radius s and infinitesimal thickness ds. Abhinanditha. Kind of like the theme of the stream is I if someone in chat has like a homework question, I answer that as best as I can. But in times like now when things are a little bit slow, I just kind of do whatever self-studying I feel like. And so today it's been doing some physics. But yeah, I mean that's like the theme of the stream. Just straight up Einstein or Boltzmann floating around up there. Space is flat. I haven't heard that. I've heard like there's like regions where it's like hyperbolic or something like that. I don't know what space being flat would mean. I believe it. I just like haven't heard it. Calculate the infinitesimal electric potential dV produced at point 0 y 0. Radius S, infinitesimal thickness ds. What formula for potential do we want here? Are we given the are we supposed to know the formula for the field this thing generates? Hyperbolic is possible not detected yet. Oh, okay. Or does flat just mean it's not hyperbolic? Or when I hear flat, I think of literally like 2 dimensions. But maybe like flat in the sense that it's like Euclidean? Integrate around the defined dB. Calculus part C. Oh, okay. I should have looked ahead. Chess Alexis. It's been a minute. You had 1620 the exam you helped me with for a question. Go for it. I'm not the best with physics, but I'll give it a try. And Api Nanditha, will you explain differentiating formulas and simple methods? It depends what you mean with like differentiating formulas. If I'll link you to the site that I really like for everything calculus. If you can maybe be a little bit more specific about like a type of derivative you want to hear more about, I can answer that. Like I would start on like this page here and keep moving through these sections if you're curious about like a specific like piece of it. You can tell if it's curved, it's like at least 20 billion light years wide minimum. Okay. Should be easy. Oh no, the thing I'm doing on screen is this was I'm waiting to hear from Avi Nanditha about if they do want a more like if they want to hear something specific about derivatives. The thing I'm doing here is just for fun, so feel free to just post your question now and we can take a look. In the meantime, I'll just keep on looking at this question. Over the entire span. Yes, locally it is curved near H mass. Okay, that makes sense. I was just thinking about what you're saying in the context of like other things that I've heard. Okay, I think that's starting to make sense then. With that like caveat. So what's your potential dV? If you want to put it in my Discord. Oh, well, it's late for you if you're in France, but even if it's in French, we like Google Translate works on images, so we can usually figure out a way to deal with it. And you can post it in like the math discussion, the math homework help channel. Pie may be normal, but I wish my wife would let me eat some. Have a great rest of the stream. All right, well thanks so much for popping by. And if anyone likes astronomy, please do check out Astronomy Show, aka Jason, and I hope I'm getting that right. Sorry, it's been a minute since I've popped into to your stream, but I do really enjoy it. Just hearing about space. Jason? Okay. I would feel really bad if I got it mixed up. I'm really tempted to, I don't know any French at all. I'm really tempted to try to pronounce this anyway because it's fun, but I'll resist the urge. Oh, okay, this might just be, okay. Yeah, from what I'm seeing from the diagram and being able to guess what some of these words probably mean, I think I kind of know what's going on here. Let me see if I can get Google Translate to work on this thing just to be sure, though. Translate.google.com, images. French to English. Oh, whatever that word is, it doesn't like that, but... Oh, okay, you provided the translation here too. Yeah, let me just use yours instead, because Google Translate will do some weird things. Determine the minimum speed and corresponding angle needed to just hit the ball. Oh, okay. The player throws the ball with a speed of 8 meters per second, and what angle should he throw it to just hit the ball? The minimum speed and corresponding angle. Ooh. Okay, so I think the minimum speed happens when your angle is 45 degrees. Is that right? Ahmed Said, you can ask questions. You can type it out there in chat, or you can put it in my Discord. It's only from level to level? Oh, dang, okay. So... we know the starting height. Okay, let me... I've never heard of the sport, but I see somebody just throw a ball at another ball. Simple enough for the physics problem. So, the height of the ball is equal to the starting height of 0.7 plus v naught cosine theta times t minus 1/2 times gravity t squared. I think it's just the formula for the height of this thing. And I hope that this looks familiar to you. This is, if it doesn't, let me know. I'm trying to rack my brain for when I took algebra-based physics, and I think we were just given that we could do something like this here. In the x position at any time is equal to, so that should be sine. V naught cosine theta time, and we can take our, I don't think we need to do plus anything. Okay, good. You two both caught that. Now, if we want the minimum velocity, what must be true? Like, we should be able to figure out something with these two equations. Like, do we want to make the vertex of this parabola as low as we can? I don't know if that's easily done, though. You still have three things you don't know: theta, delta t, and v naught. Yeah. We're starting, I guess we can, we start at 0, 0.7 and we end at 6, 0. But we don't know how much time this takes. Let's, I wonder if there's a, let's go to Google here. Minimum velocity to throw a projectile for a given distance. I assume this is algebra-based physics. I'm going to assume there's a formula here. I guess you could do some multivariable calculus, but I assume that's not the intention. Set the velocity of y equal to 0. That'll be for getting the highest point. I don't know how that would help. What? Oh, no. Oh, you're projecting to Fembox. I mean, I won't speak on Fembox's behalf, but I personally welcome a distraction. Really? You can get the equation just in terms of y and x? Oh, you take the thing I got for x and plug it in. You let t equals x over v naught cosine theta. Throw it horizontally? Is that the minimum? I think you have to throw it pretty hard to make it go that distance the fastest. Or sorry, to make it go that distance, to make it like make that distance, I think you have to throw it pretty hard. So, Chess Alexis, I guess this is suggesting a way that involves derivatives. Do you know what a derivative is? Are you able to use them in this class? Use equation to find v squared as a function of theta. Oh gosh, that's what they do angles in? So it is not far off from 45 degrees. That's more like what I was thinking. Yeah, I'm not a fan of degrees, minutes, and seconds, but that's obviously, not up to me. Um, Hey, Krish, I'm good. How about you? dv by d0. Okay. So, I guess, Alexis, do you know about derivatives? I think we might be able to use this thing here. Like this kind of answer here. Actually, multiplying this through by, oh wait, how are they dealing with the tangent theta? Oh, I guess you subtract it over. That's kind of weird though. What is this formatting? These answers are not the most helpful things I've ever seen. Okay, well, I think we can start doing some math here, but like we could say that this equation implies that t equals x over v naught cosine theta, and plug it in up here for y. The v naughts cancel. Sine over cosine is tangent. X 4.9 x squared over v naught squared cosine squared theta. And I think we can multiply everything through by cosines. I mean, for the x and y, can we plug something in for those? That's what I want to do. I just want to get rid of x and y. Like, can we plug in our endpoint? Because that's like, can we? Well, we're plug in the beginning point, we get garbage. If we plug in the endpoint, we don't. I think what I want to do is say that xy is equal to 6, 0 in this equation. I am a little bit nervous about doing something invalid here. Uh, 4.9 times 36, whatever that comes out to be. And then I want to solve for v squared. So these two things get subtracted over, but there's a negative sign in front, so it's going to become addition. Over 4.9 times 36 times cosine squared theta. And like we could take a derivative, we could find dv d theta. Secant can be put in terms of tangent. If we can do that, I don't know if we need to. Tangent is sine over cosine, so there's a little bit of a cancellation there. I guess we have to take the square root of this thing. Do we want positive or negative? I think I'm just going to say the positive square root. This is going to, oh no. This derivative will be so annoying. .7 cosine squared. Or I don't know where that would be. Oh wait, oh, oh, you're right. Thank you. Because like, this seems something like what those insights I saw online were doing. But like somewhere around this point in the math, they were taking the derivative and finding dv d theta and minimizing it. Or finding the value of theta that minimizes v. But this derivative is kind of awful to take. I feel like this is potentially wrong. Did I flip it? Oh, I flipped it. You're right. You're double right, Fembox. So I should have flipped everything there. But I feel like there's no way you're supposed to take the derivative of that thing. That just seems terrible. Like, I was hoping there'd be some kind of like equation we can use that just has done this hard part for us. We have 2 points on the parabola. Can we plug in both of them? Well, the other one we use to set up the equation. So if you plug in 0.7, oh, you mean to like find t, or if you're talking about like the equation for y, like the function y of x, yeah. Oh, wait. No, never mind. Oh, I didn't see that, no. Yeah, I'm not sure what to do with that. This is this is a harder problem than I thought it'd be. Hey JC 2407. Delta X must be 15. T from before. Hmm. This is so annoying. I think it shouldn't be that like this hard. See, my power customer logged my Wi-Fi password for the past 3 years. Should I ask it for a refund or just upgrade its firmware? Both. No, it's not your fault, Chess Alexis. When I initially saw the problem, I was like, oh, it's just projectile motion. I'm sure I can do this. But like, this is actually kind of hard. Hey, Yatsun Saini. How's it going? Physics range equation. We don't... I'm looking for a version of this that doesn't... that lets you have, like, you don't have to end at the same level that you began. I'm doing good, yeah, and I hope I'm saying that right. How about you? From which do you belong? I'm from America, if that's what you mean. Am I able to do part B? I think I could do part B, but I assume you need more help with part A. If I did make this thing, if I did make Wolfram Alpha get the derivative for me of the thing that I wrote on the board, instead of theta, I'm gonna use X just to hopefully make Wolfram Alpha not freak out. 4.9 times 36 over 0.7 cosine X squared plus 6 sine X cosine X. And we have to set this equal to 0. And let's see if this matches up with the angle. So this should be the angle that gives you minimum velocity, I think. Whatever Wolfram Alpha can find for an answer. Oh no. Pi. Oh god. Go to Wolfram Alpha. 2 pi minus 0.84? No, wait. Two pi minus 5.55586 times 180 over pi. 41. Oh no. Is that the right answer? 41 point something degrees? Oh no. They can't expect you to do this though. There has to be an easier way. Like, there's no way you're supposed to solve for this equals 0. I think it gets the right answer though. You can solve it easily in a few seconds? This? All right. I mean, maybe you're some kind of genius. I'm willing to believe you there. Okay, well, I feel like there should be an easier way, but the task would be to .9 times 36. I didn't see what that came out to be. The task would be to take the derivative of this with respect to theta, set it equal to 0, and solve for theta. And that'll give you the value of theta where the minimum velocity, that'll give you like your minimum angle. And I think that will get you the right answer. But I'm not going to do all that personally. You can if you think that's what's right, but I think there's no way like you're supposed to do something that complicated. What would happen if I thought reverse image search would be easier on this. I think with part A, at least, you stumped me. Yeah, sure, Chess Alexis. That's unexpectedly a much more difficult problem than I thought. Do you want to talk about part B at all, or were you only asked about part A? So when did it become 7 o'clock at night? Yeah. All right, well, I'm glad I'm not the only one. 4 a.m.? Oh, geez. Good luck with that one, I guess. Can't sleep if not nightmare. Oh, okay. JC 24/7? I don't really know what you're talking about. How long would it take me to work this out? Be cool to be able to finish off this midterm in one day. So I guess we want to get the potential due to a ring. Oh wait, is there a formula for potential with respect to this is probably more what I want. Right? Maybe. Because I was gonna try to. Well, it's not what I was gonna do. R is constant over that ring. True. Oh! Huh. That makes that so much easier. Do you need an integral then? So it has circumference 2 pi r, or 2 pi s. ds times sigma over y? Is it that simple? Yeah, I think it is. Times k. Oh, okay. Yeah, true. Square root s squared plus y squared. There we go. That seems neat. Part B. How are you thinking of all these questions, JC? They're kind of just random, but it doesn't seem like you're waiting for a response anyway. Radius A. If I multiply my bad jokes by your math skills, do we end up with a fundamental theorem of comedy? Are your bad jokes infinity and my math skill 0? If so, I think we have a paradox. Yeah, what even hurt me? K pi sigma 1 over root u du. I would not be surprised if I'm doing something wrong here, but who cares? You know, who actually does math to be accurate? Multiply by 2. K pi sigma, and then we unsub the u. Oh no. And I'll take out my bounds after I do the use sub, so you don't mark me off for a point. Is integrals in terms of s? Oh, well, root y squared. Root y squared is positive y. I don't want any absolute value business. Okay, that seems good enough to me. What's part C? Oh, wait, you're JC? I forgot, you're JC. Oh my god. I was wondering, like, what the heck was being put in the YouTube chat. That was my answer there, Fembox. There's actually people, usually on YouTube, who, like, are like that, so I assumed you were just, like, it was some troll, but yeah, I forgot that's you. If a goes to 0, we get 0. That's good. Oh yeah, okay. I don't know why I'm doing partial derivatives here, but, you know. It's not wrong. No, it's kind of wrong. Yeah, it's just wrong. That's really wrong. There we go. Minus sign. Wait. Do I have my direction backwards? No? You do the derivative. 2 minus 2k pi sigma something annoying 2y the minus sign over root a squared plus y squared. Minus 1. Bring the minus sign inside. 2k pi sigma 2y over root a squared plus y squared minus plus 1. That plus 1 kind of disturbs me. I feel like it's what I get though. Dimensions of the electric field. Oh, hey, now the automod worked for one of those best viewer bots. 2k pi sigma. K is whatever the hell it is. Who even knows what K is? But as long as the rest of the units are right, K will take care of itself. So we have coulombs per square meter. Wait, I guess we... Ugh. This bit here... Well, I don't really know what to think of that, +1. Isn't that unitless? Oh, wait, well, that's perfect. Because we have coulombs per meter squared, and that's charge over, that's Q over R squared, and so K takes care of the rest. Okay. Now if y approaches 0, I think it looks good. If y is much less than a, what geometry does charge distribution? Oh, it's going to act like a plane, I bet. If y is much less than a, if y is much less... Ah, brush. Give me the brush. Let's get 1 over a plus 1. Two over a plus 1. 0 over a plus 1? I guess so. Hey, Otaku Bucket. If y approaches 0... Oh, I thought it was a L'Hopital's in my head when I was mentally trying to do the limit when you said that, with when y approaches 0. But it's not a L'Hopital's, it's just 0. 2k pi sigma it's a bird. No. It's a plane. Do you know about JEE? I know enough about it to fear it, Otaku Bucket. I usually can't do the problems that I've tried. Did Cook? Okay, yeah, Cook posted the answers. Wait. Which one? D, B, I need C. Oh. It's only A, B, and D, but it's fine. Calculate the field near a uniformly charged bird. Calculate the infinitesimal electric potential dV produced at the point 0y0. 2 pi sigma k SDS. Okay, I think that matches. 2 pi means... Oh, okay. I don't actually look before I start doing things. evidently. Oh yeah, you're right. Integrate over the entirety of the disk. Just take the thing we got. Integrate from 0 to A. Uh, 2 pi sigma k. Oh, okay, then you can... Wait, what? Oh, k is equal to 1 over 4 pi epsilon naught. You make that substitution here. Okay. But either way, it's fine. Zoom and enhance. One minus, wait, did I have, were my signs okay there? Oh no, for C, I have them both positive. Oh, no, wait, where did I go wrong? Wait, I went wrong in part B? Minus Y. What? Wait, do I actually have a mistake here or not? I can't tell. I have a plus right there. When you do the derivative, oh, I stuck a negative sign because I don't know how derivative works. Oh my god, okay. When I took the derivative of this, I was thinking it's like doing 1 over a square root, so I just randomly stuck a negative sign in front. Oh, nice. Okay, that's even nicer of you, wow. I'm off by a factor of 2 in the numerator. I am. Oh my, dude, I'm washed. Actually, didn't I just break the record for my longest math stream last week? I feel like I've broken the record again. Wasn't my previous record 6 hours? And I literally said it last week. What's up with this dimensional analysis? K times sigma multiply. Oh, okay, so total charge over distance squared. Okay. Oh, sorry, Otaku Bucket. Can you suggest some great maths author books, if known? Depends on the subject. Your midterm was so I apparently it was, yeah. Oh yeah, that slightly threw off, or that threw off a little bit the final result too, but you know, who cares? Actually, no, it didn't. Mine is just in different terms. A great book on trig. I don't know one on top of my head. But either way, like, legitimately, like, thanks for passing along this midterm. It's kind of nice to have that, like, a check that I actually am retaining some of this. Oh, awesome. Thank you for finding that book. Well, there's still a two way out front. The two that I was off by was this two here. I think it is nicer to write k as 1/4 pi epsilon naught. To get sigma over 2 epsilon naught, which I think exactly is the equation for a plane. Trigonometric delights Eli Mayor. Oh, okay. Thanks for finding that. Yeah, I probably got a couple points off on that last one, but I mean, I did make it an open book test and open chat test, I guess. I think I nailed problem 5. Problem 4, I got carried on that. I should probably, if I was doing it on my own, I might have had to take the L. Dipole 1, I never even learned that. I'm not counting that. This one, I did the hard way, and I was off by a negative sign. Other than that, I'm good. This one, oh, yeah, I just kind of got lazy on that one. Okay, well, I think I did really well, you know? And that's all that matters. 2 multiple choice wrong. I can't tell if something's happening at my door right now. Just be really quiet. I don't want to talk to people. Why are people right at my door? They didn't knock. I think they're going away. Thank God. It's not like they're like some kids in an adult. I wonder if they're just like putting flyers out. It's me. Okay, well, I would give myself probably a C. Now I actually look back through the ones that I got wrong. I feel like I was pretty close on basically all of these though. Like 9 was a stupid mistake. Okay, I should really end things. 6 hours and 40 minutes is too much. Let's end the YouTube stream here. So when I was here on YouTube, I appreciate you. Back on YouTube on Saturday.